Hello. We are just in time for a Starliner conference. Are you ready to Starliner? I'm ready. Are you ready to go? I'm ready to go. Are you ready to go? Your stream is behind. Okay.
NASA, Boeing, and ULA team.
All right, fine. We'll start at the beginning then.
Discovery, go at throttle up.
I'm ready. I'm in the mighty USA now. Hey, alleviate. I'm glad the move went okay, dude. That's awesome.
To start, we will hear from NASA
All right.
Associate Administrator Jim Free.
All right, Jimmy, what do you got?
Thanks, Stephanie, and good morning. Thanks for joining us here today. Our NASA ULA.
Yeah, no, I hear you, man. I'm glad the move went good.
Couple weeks on analysis and testing for that.
But we're already a little bit behind, so I'll just pause it. I'm happy you're here in one piece, dude. It's good to have you on board, my friend. Good to have you on board. Welcome to the freaking party. Soy el fiesta. Anyway, that's cool, man. I'm glad you and yours got here okay in one piece. And you set up. That's awesome. Should be good. As the great Jeremy Clarkson once said, "Welcome to freedom. You'll like it here." Yep. Just flip that one around. That was an obscure Top Gear episode reference, but hey, whatever, it's fine. Anyway, so we have an update to the crew flight test. We're gonna figure out, get some transparency here about what's going on with Starliner and why it was moved to June 1st. So, in true interview style, when we listen, sometimes listening is more important than talking. So I am shutting up, and I'm going to listen to what these fine folks have to say here. Good to see you live after I just come out of an exam. Well, Matt, you are just in time for a media teleconference. Oh, this is going to be great. Today is Friday in California. All right, EJ shutting up time. Let's go.
Atlas V and Boeing Starliner to prepare for that first crewed flight test to ISS. Most importantly, I want to thank all three of those teams who've been working those issues, doing the analysis, thinking through all the scenarios, talking through things as a group, sharing information to make sure that everybody had the latest technical information so that they could make the decisions and feed things up to the managers, which you'll hear from today. And we are learning more about the systems every day. I also want to acknowledge to you all that, we've had our effort focused on addressing these technical challenges, getting to the right solutions. Each one of the technical issues that you hear about today, we're moving pretty quick and learning and kind of one flowing into the other, which we wanted to get all that information together to inform you and find the right time to do that, and that date is today. And I know there's some frustration out there about us sharing information in a timely way. I can assure you that the teams were working up until late yesterday coming to a conclusion. So we wanted to make sure that we had everything in line and in place for you, and you'll hear about that today from Steve and Mark and Gary. We do hear your concerns and comments about the flow of information, and that's my rationale. I'm happy to answer your questions about the rationale, but please know that getting this to you and getting the complete story has been our goal. You are an important part of telling our commercial crew story, and we'll continue to adjust our approach as we find the right balance of providing those updates as we learn more information going forward. So this morning we're going to hopefully remedy that. You will get a lot of information from SOX and from Steve and Mark and Gary to share with you where we stand and what we see as a possible path moving forward. I'll let them share those details as they have been very much in the working meetings to solve all these, and I can assure you they have been there. I appreciate everyone that's been involved, every individual working tirelessly to advance our understanding of this system as we move through each of these issues. It's our collective job to ensure we can fly this test flight safely and successfully, and to do that, we're going to understand everything about these issues and make the right decisions. That's why we're taking our time. We need to be deliberate about it. This is a new spacecraft and a new system. We've all challenged the teams to stay vigilant, and we've already, uncovered some of the unknowns that you always hear about when we talk about flight tests, and it's better that we've done that on the ground. We're going to keep learning from this mission, and I'm looking forward to increasing the knowledge of this system and flying with crew in this system as we get to ISS. This is all working towards giving us that dissimilar redundancy that's an important goal of the Commercial Crew Program and essential to our continued decade of results aboard the International Space Station. It's preparing us every day for the missions to low Earth orbit. That'll open access to space to more people and is greatly informing our human exploration to the moon and beyond. With that, let me turn it over to Ken Bauer-Sox. Go ahead, Sox.
Hey, thanks, Jim, and thanks everybody who's online for being here with us today. We really appreciate your interest in what we're doing. Yesterday, I had the opportunity to sit with representatives from NASA, Boeing, ULA, and Aerojet in a program board. I was only there for a small part of the meeting, but for the time I was there, it was just impressive to see the team working so thoroughly, so collaboratively through a very, very complicated issue. One of the things that popped out to me was this is why it's taken a while for us to be ready to discuss the issue. It's so complicated. There's so many things going on. We really just needed to work through it as a team, and it was impressive to see folks in that process as they converged and reached a plan for us to move towards launch. So thank you for your patience as we've worked through that. I know you're eager to hear more details, and so now I'll pass over to Steve to share some of those details.
Yeah, thank you, Ken, and thanks to all of you for being here today on the Friday before a long Memorial Day weekend. Appreciate your interest in human spaceflight and the Commercial Crew Program, and I want to thank you for your patience.
I am interested.
As our joint NASA, Boeing, and ULA team work through 3 specific issues over the last 2.5 weeks. Our goal today is to provide a comprehensive update to you on what we've been working on, what the resolution of each of these items are, and then to take questions that you might have. I would say I want to kind of set the stage for what it's been like for our team over the last 2.5 weeks. As you know, in Commercial Crew, we have a small, focused team, and we've been working very hard. You'll get a sense of that work today, minus the long hours and probably lots of coffee. So if we step back, we last talked to you after the launch scrub on May 6th. That was the scrub for the Centaur self-regulating valve, which we'll talk a little bit more about. I want to talk 3 aspects of the work we've been doing over this time frame: the swap out of that Centaur self-regulating valve and the checkout and how complex that activity was, a helium leak that we discovered in one of the doghouse manifolds on the service module for Starliner, and then I would say the implications for that leak and what it meant to the rest of the propulsion system relative to the deorbit burn. So let's start with the Centaur valve. That was the first thing that we worked on, and that was what caused the initial scrub. After the scrub, we got together and we looked at the data for that Centaur self-regulating valve. We determined that the number of cycles that it saw was outside of qualification. When I say we, this was a joint NASA and ULA team working side by side. So that valve had exceeded the number of cycles that we saw in qualification, so we couldn't go fly that valve. We obviously rolled back from the launch pad to the vertical integration facility, and we swapped that valve out, and Gary will talk a little bit more about that.
Gary?
We looked at all the data for the new valve, its performance. We went and looked at what we call the acceptance test packs. We didn't see any issues, nonconformances with that valve, and so we proceeded with that swap out. Now, that swap out was a pretty substantial activity, and that's why we adjusted the launch date from the May 10th to the 17th. And let me explain why that was a complicated activity. When the valve has to swap out, of course, the Centaur is an awesome stage. We've been flying it since the 1960s, but it's a pressure-stabilized stage. And so in order to swap this valve, the Centaur LOX tank and fuel tank had to be depressurized. In order for that to happen, we had to offload the weight on the Centaur, essentially. And so we used a crane to lift the Starliner not off of the Centaur, but to pull up on the Centaur and to take the load off the Centaur stage. In order to do that, we had to go back and do an analysis of all the load paths, and just to make sure Starliner is certified to be lifted with a crane. That's certainly the way it's moved for weight and CG in the processing facility that Boeing has. It's also the way it's stacked and assembled on the launch vehicle.
Yep.
But we weren't unbolting it this time, so we were applying a little bit more loads to the same load path we used to lift it. We had to go through that analysis, working with the joint Boeing, ULA, NASA team. We did that. We did that operation over the weekend of May 11th and 12th and replaced the valve, and Gary will talk more about that. So we got through that. In the meantime, so that's the Centaur self-regulating valve. When we had the launch scrub on May 6th, we discovered in one of the helium, what we do after that launch scrub is we sort of safe the propulsion system. And part of that safing is to close what we call helium manifold valves. In each of the dog houses, those are the rectangular dog houses. There's 4 of them, port, starboard, top, and bottom on the service module. There's a helium line that goes into each of those dog houses. There's actually 2 helium manifolds in each of the dog houses. Those are used to open and close valves on each of the thrusters, the RCS thrusters and the OMAC thrusters. When we closed that system after the launch scrub, we saw a small leak in the port manifold 2 doghouse when we closed the isolation valves. It was a very small leak at the time. It was about 7 psi per minute, and that may sound like a big leak, but again, this is a really small volume. It's about 15 cubic inches of volume, and so when we close that valve, it doesn't take long to see a leak in a very tiny volume. That size is about the size of a softball, if you just think about that, 15 cubic inches. So we saw that leak at the pad. We rolled the vehicle back to the vertical assembly facility, and we wanted to troubleshoot that leak a little bit more. And so we cycled that manifold open to bring it up to the flight pressure, which is about 750 pounds per square inch. And over a couple different cycles, we saw that leak rate grow. It went from about 7 to on the order of 50 to 70 psi per minute. So that gave us pause as that leak rate grew, and we wanted to understand what was causing that leak. In order to do that, we took off the cover on the port doghouse, and the Boeing team took a leak detector and looked all across that particular doghouse for leaks. It's a device that measures the helium that could come out of any point in the line. When we did that, we were able to isolate the leak to one of what we call a flange on a thruster that's called the P2D2 RCS thruster. This flange is about the size of a deck of cards, so it's a pretty small flange. But in that flange, there is a helium line that comes in, a MMH line, the fuel, and then NTO line, nitrogen tetroxide line, that comes into that flange into the thruster. So we couldn't immediately open up that flange to look at what was going on and what was causing this leak in the helium system.
Okay.
So we had to do an analysis-based approach to go understand why we had this helium leak. We knew the leak was there, and we knew the size of the leak, and we actually knew in this flange which side the helium was coming out of, but we couldn't open it up because essentially the system was not safe for humans to be around and open that system up.
Yep. It's fueled. You don't want to do that.
So in addition to the cycle testing that we did, and we also looked at all the other manifolds, so there's 8 total helium manifolds. Only one has showed the leak, and that's this port doghouse helium manifold 2. So when we went through the
20 minutes,
troubleshooting
Sizer?
for this, we figured out that the others are not leaking at all, but we wanted to understand what was the potential cause of this. And so we went and worked with a team to look at potential failure modes within that flange. We figured the most likely cause of the leak is a seal that seals that flange. In between the two metal parts of the flange, there's a seal, much like you would have on any piece of your plumbing at home, a faucet or anything like that. There's a seal that keeps that interface tight so that the helium can pass through there. We had to do special analysis on the seal. We brought in seal experts from Boeing and NASA to look at that seal, to look at why it could be leaking. We figured out that this potential seal could have a potential defect in it, and over time as we cycled it, that defect grew a little bit, and then that was the cause of the leak. We also did a structural analysis of that helium flange to look at when you have a seal, you want to make sure that seal is in the groove, if you will, and you want to look at the sealing force in that particular in the groove. And
That's
we had
just
a finite element analysis
valve.
done, a very detailed structural analysis to look at that.
It looks
that
something like
squeeze on
that.
the seal. We felt like we had a really good seal there on all the other manifolds, and that's why we are confident in this case. There's 28 RCS thrusters across the vehicle, and 27 of those do not have a leak, and the one has a leak. We looked at also, with that leak rate, what if it gets worse? So how do we manage it in flight if that leak rate in this port doghouse helium manifold 2 got worse? We can accommodate leaks in multiple manifolds. Should that happen, should we be wrong about something, we could handle up to 4 more leaks, and we could handle this particular leak if that leak rate were to grow even up to 100 times in this one doghouse. So again, we needed to take the time to work through this analysis and to understand the helium leak and understand the ramifications of that, and that's why it's taken a little while to get back to you.
Pretty much, Elvis.
Now,
Sounds like
as
somebody
we
over-torqued it.
studied the helium leak, we also looked across the rest of the propulsion system and just to make sure we didn't have any other things that we should be concerned about. We found a design vulnerability, I would say, in the prop system as we analyzed this particular helium leak, to where we didn't, for certain failure cases that are very remote, we didn't have the capability to execute the deorbit burn with redundancy. And what I mean by that is Starliner is certified to perform the deorbit burn with 3 different techniques. We can use 4 OMAC thrusters, 2 OMAC thrusters, and 8 RCS jets. If we had the right circumstances of failures, we could lose the 8 RCS jets. And so we wanted to take extra precaution to understand what could we do if we lost those 4 thrusters. We worked with the vendor of the thruster, Boeing, and our NASA team to come up with a redundant method to do the deorbit burn, to break it up into 2 burns, about 10 minutes each, 80 minutes apart, to come up with a 4 RCS thruster deorbit burn, and to regain the capability of the original system. And that took a little time for our team to go work through. Our guidance navigation control team, our structures team, our propulsion team, working hand-in-hand with Boeing and the vendors for these systems. And so we have that, restored that redundancy for the backup capability in a very remote set of failures for the deorbit burn. So it took a little bit of a while to work through that. Because we had that particular system vulnerability, we decided to have a Delta flight readiness review, and that is primarily because some of the human rating certification details have changed from what everybody who signed the interim human certification document for CFT has changed. And so we're going to have a Delta flight readiness review on May the 29th to review both the leak and the changes to the way we would execute a deorbit burn in a remote set of failures. Long term, Boeing is going to explore options as we work towards certification after the crewed flight test to recover this redundancy. They are evaluating potential software fixes or other changes that we could have to restore that capability. I have spoken to the crew several times. We've stayed in contact with them. They've been a part of our meetings. Their job, as they know, is be ready to fly. They've been in quarantine now for a little over a month. they're in good spirits. They've tied into our meetings. They advised us to get some rest, which we're going to do now that we've set up for the launch on June 1st with the Memorial Day weekend, having our team, who's worked very hard for 2.5 weeks, to have a little bit of downtime. She says that the crew has also been in the simulator looking at various failure cases, some of them very extreme, should we lose various thrusters and various manifolds. And they have flown all those cases in terms of rendezvous and deorbit and entry, and they're ready to go. Butch, when we talked to him, he said, we're in the business of discovery. We've obviously had some discovery over the last few weeks. He knew going into the flight we would have some discovery, and we've had it prior to launch versus in flight. And Butch says that they're ready to go and when we're ready to go. So what's next for us? We had a program control board yesterday where we went through the two topics in detail, that being the helium leak and the port manifold 2, and then the implications for the redundancy for the deorbit burn. We feel like we're on a good path. We have a few actions to close. We'll follow that up next week with a Delta program control board, and then we'll have the Delta agency flight test readiness review next Wednesday. And then the following day, if that review gives us a go to proceed, we'll roll the Atlas V and Starliner out to the pad, and we'll have the Starliner mission management team the next day.
Go at throttle up.
And then we'll come back and talk to you again next week after the review and let you know the latest status. And we've already talked about the launch dates. This is an important flight for us. It is not easy. I've been in human spaceflight for 37 years, and there's challenges with every single flight. There were challenges in Space Shuttle. There's challenges with the Orion vehicle that we're learning about as we flew that test flight, and there's challenges in every vehicle. So we'll work through those,
more or less, AP.
Those challenges one by one.
We're about
I'm extremely
5
proud
minutes
of the
behind.
teams. They put in long hours, worked over the weekend. The joint NASA, Boeing, ULA teams working through this integrated set of problems. We're really looking forward to having the second crew transportation system online soon when we're ready to go, and so we can continue to do the great research on ISS. This is why we do a test flight. There's always learning in every flight that we fly, whether it's a test flight or another flight. I'm super proud of the team, and Gary and Mark will add some more details. And with that, I'll turn it over to Dana Weigel.
Thanks, Steve. And thank you all for joining us today. I really want to extend my thanks and appreciation to the Commercial Crew Program, the Boeing, and our technical teams for the extensive analysis and work that they've done these past couple of weeks to get us to this point. They've really worked diligently to understand this helium leak and the implications associated with the fault tolerance and to make sure we can fly safely. These are some incredible teams, and I'm really grateful for the long hours they put in to get us to this point. From a station standpoint, we, of course, have followed along with all of the work. Our responsibility is really for the integrated operations risk realm, meaning for safe rendezvous, docking, the vehicle being on board station, and then undocking. And so kind of the sphere, if you will, around ISS. So we've worked through all of these challenges as well. We're really happy with the plan. We think we're in great shape to support integrated operations from a station standpoint. Of course, in the coming days, as Steve said, we'll have another flight test readiness review where we'll get the broader community to do another pass-through and look at all of the great work that the team has done. This is a really critical and historic mission for NASA, Boeing, and, of course, the space station program, as Steve mentioned, to get a second U.S. crewed vehicle capability up and flying to space station. We're going to take our time to get there. We're going to make sure that we do it right and that we do it safely. In other space station news, we continue to be really busy on board. The crew has been working on research. They've done a number of equipment replacements for us, and they're starting to step into some of the EDA preparations work in support of the upcoming spacewalks that we have in June. Next week on Tuesday, May 28th, we have a Progress undocking. That's Progress 86. And then we've got Progress 88 launching on May 30th at about 5:45 a.m. Eastern Time. It's launching from Kazakhstan. It will be carrying thousands of pounds of supplies.
Very nice.
It's going to be docking to station on June 1st around 7:45 a.m. Eastern Time. So as always, a lot of things going on board Space Station, but we are ready to support Starliner, Butch, and Sunny when they arrive, and we are very much looking forward to supporting this historic mission. And with that, I'll pass it over to Mark Nappy.
Good morning, and thanks everyone for joining us this morning. Steve talked a lot about the leak and the we call fault tolerance issue. I'm going to repeat a little bit of what he said, but not to just repeat it and say it again, but to add more context on how we address these issues and how thorough the whole process was. Like Steve said, it's completely partnered. We utilize skills and experts from across NASA, Boeing, and our suppliers to get to the right answers and build flight rationale. Timeline of where we got to, we scrubbed on 5-6, rolled back, ULA went first and worked on the valve, and then we got right in there and started looking in at the leak that was discovered on the scrub operation. By 5:13, we had located the leak. We had checked all the potential sources. There were over 30 different sources that the team had identified. And then we went back a couple days later and we proved to ourselves that the leak was stable. That's all good data, but that really starts the process of, okay, how do we solve this? How do we get flight rationale? How do we determine what we're going to do next? So there were a couple of questions that we had to answer. First, why wasn't the seal in this joint sealing? Exactly why. Will it get worse? How much worse can it get? Does the condition can the condition exist in the other flanges? Is there some kind of common cause? And then if we were to accept this, would it be operationally manageable in flight? And can we tolerate it, or are there workarounds? So that really is what took a lot of time for us to go resolve, was answering all these questions. And of course, during answering these questions, we found that design vulnerability that Steve talked about. He said it was remote, and I'll point out that it is very remote. When we looked at the fault tolerance of the system, there are over 17,000 potential combinations of failures, and what we found was that 99.2% of them were all addressed, and this small 0.77% is what we found. So that puts into context the remoteness. To address these issues, like Steve said, we just covered the landscape with all these modeling experts and suppliers and system experts, designers, and then even did independent verifications of the results once we got them. We met nearly every day, either in some kind of mission management team or a control board, to hear status, to hear results, and to get everybody installments of what we had learned each day. The teams, went under some pretty immense scrutiny to be able to explain the issues that we were finding. They got pressure tested on their conclusions, and then, eventually we got the community bought into our flight rationale and the actions. So bottom line, Ken said that these are complicated issues, and they are, but it boils down to a couple of things. On the leak, the design meets the intent for this application, so it's not a design problem. We don't believe we have a common cause where this condition exists across all the other flanges, which is good news. And we are comfortable with the causes that we've identified for this specific leak location. And if the seal completely blows out and we had just metal-to-metal contact, we know we can manage this. So this is really not a safety of flight issue for ourselves, and we believe that we have a well-understood condition that we can manage. For the fault tolerance, or as Steve called it, the design vulnerability, again, extremely unlikely set of multiple failures that would have to occur for us to get into this situation. And if it happened before we undocked, we wouldn't undock. So we would manage it and be able to address it there. If it was to happen after we undock from station, again, extremely unlikely, but we have now a solution with this 4 RCET jet scenario that Steve walked through. It's backed by test data, it's backed by flight data, and the guidance and navigation modeling have reinforced that this technique will work, and of course we've had independent verification on that. The crew has tested it, and we feel very comfortable with the situation that we have. So again, very low level of risk for an unlikely set of failure scenarios, and we have a safe for flight vehicle that we need to put just the final set of flight rationale together in the coming days, and we'll be ready for these sets of meetings that we have in front of us. The minimal work left in order to get to launch next Saturday. We have of course, a lot of meetings to go through with control boards and the Delta FR that Steve talked about in the L-1 and L-2 day. We chose 6-1 for a multitude of reasons, but one of the big reasons was to give the workforce the weekend off. We've worked some really long hours, 7 days a week to get to where we are today, and we just thought it was a good idea to take a break this weekend, reset everybody's batteries, and then gear up for launch next Saturday. Remember, this is a test flight. We're still learning. We'll continue to learn. We really like to thank NASA, ULA, and our suppliers on how they came together with our Boeing team to execute this mission and to get to next Saturday. Thank you, and I'll turn it over to Gary.
Thanks, Mark. First, I want to thank all of you for participating today and your interest. I speak for the entire ULA team that we're really excited as we progress to the next opportunity to fly the crewed flight test. Like Mark and Steve have talked, we've spent the last 2 weeks working integrated collaboratively together between Boeing, ULA, NASA, and suppliers on both sides, working through the issues and preparing the hardware for flight. Steve walked you through a pretty extensive explanation of the process that we went through to replace the self-regulating vent valve. Structurally, we had to relieve the load off the Centaur when we got back to the VIF. So we attached that GSE to Starliner and applied that force, which we refer to as putting the Centaur stage in stretch. So it transitions from pressure stabilized to structurally stabilized with that assist. That enabled us to depressurize the tanks and get in to access the valve and make that replacement. So the team replaced that valve, then subsequently repressurized the stage and conducted functional checkouts of the valve assembly and did some system purges to make sure everything was operating as it should, and then put the rocket back into a configuration that would support continued processing. So after the scrub on May 6th, that took us to around May 13th to get all that work completed to be able to proceed. And then we worked, from an integrated perspective, since Starliner's on top of the rocket, with the Boeing team to make sure that they had all the support they needed to look into the helium leak in the VIF. The rocket remains stacked there in the VIF and poised, ready to support as soon as the NASA, Boeing, and ULA team are ready to go to flight. Just forecasting going forward on the activities, we will likely spend Tuesday and Wednesday of next week performing continued closeouts of the vehicle. In parallel, we'll do the flight test readiness review with the NASA Boeing team. And then subsequent to that, we would plan to roll on Thursday of next week. Friday, because of the launch time being earlier in the day, we'll have a crew sync day, get the team realigned for a launch attempt on Saturday. And so look forward to any questions. Appreciate your interest. Thanks. Stephanie, over to you.
Okay, thank you. Thanks for all those opening remarks
Ready for
from
the fun
our
part?
Speakers and the
Here
detail
comes the fun
that you
part.
shared with us. We'll now address your questions. We do have quite a few people on the line, and I know you all are eager to ask questions, so please do remember to identify to whom you are addressing your question, and please please do stick to one question so that everybody gets an opportunity to ask their question.
All right, let's see how long the one question format
If you need
lasts.
a reminder, you can press *1 to get into the queue. If your question was asked, you can remove yourself by pressing *2. So let's jump right in with Bill Harwood from CBS News, please.
Hi, thanks for doing this.
Yeah, thanks, Stephanie. It's Bill Harwood, CBS. I think this is for Steve. I'm not sure I understand the loss of redundancy issue for entry. I mean, that's something obviously you discovered, I'll say out of the blue, while you were investigating, across the propulsion system. But I don't understand what gets you into that situation, and why. I just don't understand it. So maybe if you could provide a little bit more detail, I'd appreciate that. Thanks.
Yeah, Bill, that's a good question.
Good question.
It's complicated. It probably is not so much for entry, I would say, but it's really for execution of the deorbit burn. So the cases that we would worry about here would be a case where you would lose two manifolds in what I would call adjacent doghouses. So in other words, it needs to be the port doghouse that you would lose. And this is really a little bit independent of the leak per se. So if you lost the right manifold in port doghouse and, let's say, the top doghouse, the way the software works for deorbit is when you lose, for the OMACs, for example, they're big thrusters. They are about 1,500 pounds of thrust. And so in the 4 OMAC version of deorbit, you would have one thruster firing in each doghouse, one OMAC thruster. In the 2 OMAC case, you can have them firing in, I would say, doghouses that are across from each other. But if you were to lose 2 adjacent doghouses, essentially it takes out any OMAC deorbit capability, and you don't have the 8 RCS thrusters. And so that's the case we would have to downmode to the 4 thrusters. So it's a pretty diabolical case where you would lose 2 helium manifolds in 2 separate doghouses, and they have to be next to each other around the clock, right? If you think about these doghouses going around the clock on the Starliner service module, they'd have to be total loss of the manifold and right adjacent to each other. And so that's why, as Mark said, this is a pretty remote set of failures. And so we figured that out, and we have a backup way to do the deorbit burn with 4 thrusters, breaking the burn up into 2. And it's a pretty deep failure case. This vehicle has lots of thruster redundancy.
Yeah, that's
thanks for that explanation,
super
Steve.
Unlikely to happen.
Our next question comes from Jeff Faust of Space News.
Hey, good morning. Question for Mark. If you're not able for any reason to go on June 1st or any of the other dates in early June, how much longer can you remain stacked on top of the Atlas V before you would have to destack to address any sort of propellant issues or anything else life limiting on the spacecraft that would need to be refreshed? Thanks.
No, it's smaller.
Yeah, we've looked at that, and Starliner is really not the governing factor here. It really is the launch vehicle.
Solid rocket
I'll turn it over
boosters.
to Gary to address where we would go if we miss these opportunities.
Yeah, Jeff, that's a good question. As you guys know, there's a series of things that we refer to as limited life. We have batteries. Primarily, we have a large number of tests that we have to conduct on a regular basis within the ordnance system, focused on FTS, safe and arm functions, and other pyro valve cartridges, things like that, that we would have to repeat tests on. And so those expire, I will say, throughout June and into July. And so from a limited life perspective, we would work through those items, do those retests, and swap out the hardware that's needed to be able to continue to support. In parallel, we'd have to work with our other customers for the manifest for the rest of the year to make sure that we can deconflict, and some of it will come down to a prioritization of missions throughout the rest of the year. And so we would be looking for NASA and primarily Space Force customers to work with us to identify those priorities and to sequence the mission. So that would be forward work.
I was wrong. It's not so much the solids. It's the the SRBs are just derived from ICBMs. So yeah, they're designed to sit in a silo. So I guess that solid rocket thing applies to segmented SRBs, not cased SRBs. But he was talking about pyro valves. Pyro valves, in case anybody's wondering, it's a valve. So it could be for fluid, could be for pneumatics, could be for whatever. Pyro valves are basically a one-time use valve. It's basically a shotgun shell attached to a pipe, right? It's not a shotgun shell exactly. It's a pyro. It's a little explosive, and basically what it's designed to do, it's a one-time use valve. Pyro valves are only used once, and once the pyro valve is triggered, that valve never closes again. It's a one-way valve. One-way valves are used in thruster systems. They're used in propellant systems for what's called a single use case. Pyro valves are all over the place.
And the manifold associated
with expendable launch vehicles.
And we have
and even
seen
some
that the
reusable
leak
ones
rate
too.
Isn't changing. And so what we plan to do in flight is essentially that manifold gets open. All the helium valves get open during what I would call prop activation during the launch countdown. You want to have all the thrusters available for launch should you have the unlikely chance of a mass on the board. And so it remains open, and we'll be feeding that leak, and we can actually see kind of what the leak rate is when we open that system on the pad, and we can convince ourselves that the leak hasn't changed once the system is opened. We would keep that system open all the way through docking, and then sometime after we dock to ISS, we would then close all the heliums. We sort of deactivate the prop system once we dock to the International Space Station.
Yep.
And once we close that manifold and all the other manifolds, once we dock, then we can kind of see that what the leak rate has done. And then the plan for undocking is we would open all the heliums and have everything available for undock. And so that's sort of how we'll manage it in flight. And then, Mark, I'll let you take the second part of the question.
Sure. So the common cause, what we looked at was the design first to see how the design intent was met. And after several reviews with several experts, the design intent has been met. So that makes us feel comfortable that had the seals are installed properly in the other flange locations, that this doesn't exist. An evidence that this doesn't exist is the fact that all those other flanges are not leaking. They are solid, no leakage whatsoever. So that brings us to the conclusion that we have a pretty good installation on those seals and those flanges.
And I would add a little bit to what Mark said. We went and looked at the vendor. The vendor provided 59 seals that we looked at to inspect them to see if there were any defects on those seals. We also looked at the dimensions of those seals. We didn't see any issue with any of those. Those are from the same lot. The way things happen in spaceflight is you want to make sure you have lot traceability on the hardware you're flying. So those are on the same lot that were installed in the service module. And then the structural analysis really said that the joint should not leak with this particular seal configuration. Anytime you have a seal, you have something called squeeze. Essentially, are you really pressing on that seal, and that seal, that press of the two flanges on the seal, and then also the pressure that comes in, keeps that seal in place to make sure we sealed. So we have pressurized the manifolds multiple times. The only one that's leaking is this port doghouse helium manifold 2, and then we have an analysis that backs that up that says, we don't expect the others to leak. And I think that's the confidence that we have that we don't have a common cause failure mode.
Thank you. Next in the queue is Jonathan Seri from Fox News.
Yeah, good morning. Thanks for doing this. My question is probably for Steve about those backup launch dates on June 2nd, 5th, and 6th. Do you know what times of day you're looking at for each of those backup days?
Yes, I do have that information. The launch time gets a little bit earlier, so June 2nd, the launch time is 12:03 p.m. Eastern. And then we move into the morning on June 5th, 10:52 a.m. Eastern, and June 6th, 10:29 a.m. Eastern.
Thank you.
Thank you, Steve. Next question is from Gina Sinceri from ABC News.
Yes, thank you. You mentioned earlier that the helium leak wasn't something you were monitoring during the actual launch attempt. Is it not necessary to monitor this? I just don't understand that. If you could explain it for me.
Yeah, let me try, and then we'll see if Mark has anything to add. The helium leak is difficult to monitor during the launch count. We can detect helium leaks, but the way the system works is when you activate the prop system and you open up all the plumbing, all the valves that allows helium to flow from the tanks inside the service module throughout the system into those dog houses, it's very difficult to see a leak that's this small. So we also think that this particular seal likely, because we talked about 27 of the 28 flanges aren't leaking, we think, and we haven't had a chance to put eyes on the seal, obviously, because we can't take the flange apart, but we think there was likely, in talking to seal experts, there was some kind of defect in this seal. When they're manufactured, they have some propensity to have a kind of a place where the two sides come together, like a seam. That could be a defect, or when they trim some of the material as it comes out of the mold, maybe there could be a little nick there, and then as you cycle it a few times, perhaps that the leak got worse. And so it's very difficult to see a leak until you isolate the manifold. And that's when we saw the leak, is when we isolated the manifold.
Good safing procedures.
We identified the leak.
Thank you, Steve. Our next question comes from Marcia Dunn from the Associated Press.
Oh, yeah, it's probably for you, Steve, again. As I recall, there was mention of this helium leak during the countdown before the scrub. And if not for the rocket valve trouble, would you have launched back on May 6th, given this small leak as it stood back then? And
that would have been my question.
So what's the worst that could have happened if the leak grew in orbit? Thanks.
Isolate the valve.
Yeah, that's a good question, Marcia. We
not bad, Endo.
Didn't see the leak during the countdown per se until after the scrub. So we had no way to see the leak until the scrub. So it was after we scrubbed for the Centaur self-regulating valve that we saw the leak. So if we hadn't had, I'll answer the question this way. So if we hadn't had the scrub with the Centaur self-regulating valve, we would have launched. And likely when we closed the manifolds after docking, we would have seen the small leak, and we would have been able to manage it in flight just fine. We would have done the same things. We have at least 7 or 8 days while docked. We would have done the same kind of analysis relative to the size of the leak that we could accommodate. We would have looked at the back half of the mission relative to how many feet in the leak after you undock and what that meant for the orbit. And we would have managed it in flight.
That's why they talked about that twin NOMAC thruster failure mode that Bill Harwood asked about, because they're crunching the numbers. It's actually pretty damn good analysis, guys. I'll be 100% real with you. Good job on Boeing for doing their due diligence.
The scrub take place and being able to see
real good,
because we now know exactly where it was. We have done all the work that we just talked about to understand the root cause, and that's going to help us with improving the system in the future. So, had we launched, obviously it would have been a safe flight and a successful flight, but we would have not known as much as we know today.
Bingo.
Okay, thank you. Next question comes from Irene Klotz of Aviation Week.
Thanks, Stephanie. So for this next launch attempt, now that the leak is known and well characterized, is there anything that can be done to monitor it during the countdown, or is it going to be the same situation that it was on May 6th, where it won't even really register unless there's some other issue that happens that causes you to close the manifolds down? I'm sorry, that's probably for Steve or Mark.
I'll take a cut and see if Mark wants to add anything. Now that we know the approximate leak rate, the size of the leak, the 70 to 80 pounds per square inch per minute, we have characterized what that leak looks like with the manifold actually pressurized, and we can see repress cycles from the helium tank. And so it'll take us maybe an hour after we bring the system up, but we can look at how those repress cycles are going and determine if the leak is about where we think it is today. And so that's what we're going to do pre-launch is we'll watch the system repress. If it were to change or grow, we would then go isolate that manifold and see if we have anything else going on in another manifold. We could do that. So hopefully I answered your question.
I'd only add that our mission director, Laura Kane, and our mission ops team have looked at this information and have developed a plan in case we see something different, or if we see it again, what exactly we're going to do and what the limits are on taking action. So we're prepared to go into the launch countdown.
Okay, thank you both. Next up is Chris Davenport from the Washington Post.
Did I hear that right? They're not.
Hi, thanks so much for Steve, I guess. Just real quick, I know you were looking at the helium leak, and then that's when you discovered this redundancy issue on the deorbit burn. But is that related to the helium leak? Is the helium leak causing this concern about the redundancy? I just wonder if they're related. And you had said that this was a design vulnerability. So I'm just sort of wondering, why it's just being caught now, if it's something you think you should have been caught earlier. Thanks.
Yeah, that's a very good question. Yeah.
No, it's not.
I think the helium leak itself caused us to look a little bit more detailed at the manifolds and how the thrusters were architected off of each of those manifolds. And then we started looking a little bit more detail at some of these failure cases where you lost an entire helium manifold in one of the doghouses and then in others. And that's when we started to realize that when you have a total loss of a manifold, you could lose, in this case on manifold 2 in the port doghouse, there's 6 OMAC thrusters and 4 RCS thrusters associated with that. I think that's when we started to realize that in this particular case, for this very remote set of failures, we could lose the redundancy of the 8 RCS aft-firing jets for the orbit. So it just took us a little time to figure this out now. Question is, should we have seen this earlier? I think maybe in a perfect time frame we might have identified this earlier. My memory from shuttle is we had certain failure cases where we identified some kind of redundancy issues. We'd have to go back and get this set of circumstances. I do remember one time and I don't remember if this was the liquid hydrogen eco sensors or where, but we had great redundancy in the system. However, like in a wire bundle, we figured out that we were running all the signals for a particular piece of instrumentation or avionics through that same wire bundle. So effectively, we didn't have redundancy, and we didn't have separation on the wire bundles like we should have had. So I think these things happen in human spaceflight. It's very complex to look at the architecture for power and data to each thruster, then how you get the fuel and oxidizer from different plumbing to each thruster, and then the helium source for each thruster. So there's probably on this particular design a few more things that go to each thruster that could lose the thruster, and we had identified almost all of them, but this one set of unique circumstances we didn't quite catch in our review.
Thank you, Steve.
Yeah. It's an extremely remote failure mode, guys. That's
Hey, thanks. Question for Steve. You say you think the leak, just so I'm understanding correctly, you say you think the leak was caused by a potential defect in the seal. And shouldn't the cause of the leak of the weak seal be something that you guys kind of want more certainty on before flying, or do you have more certainty on a different scenario? And if not a defect in the seal, for example, what else could it potentially be?
Over torqued flange.
Yeah,
all
it's
day.
Very good question. When we talk to the seal experts, there's a few different kinds of things that can happen to the seal. You can have, like I said, a manufacturing defect. You could potentially have an installation error where you put the seal in and it got squeezed or crimped a little bit.
That's my guess.
It turns out that the best thing for the seal is, like we're going to do in flight, right? We're going to go pressurize that seal for flight and then only depressurize it. Won't take any pressure off if there's no leak at all on orbit. But it could have been a defect, could have been a manufacturing defect, could have been an installation defect. On our fault tree, could have been some FOD in the system, some kind of small thing that maybe rubbed a bit as we pressurized and unpressurized it. So those are kind of the things that we would say are on the fault tree. The beauty of our flight rationale for CFT, the crewed flight test, is that we have looked at the other 27 seals and the other 27 flanges by doing a long-term decay check when we were in the VIF. I think it was almost 3 days where we sat and we had the manifold closed. We weren't really feeding helium into the system. Those other manifolds were leak tight, which meant the flanges on those manifolds were leak tight. And we also, have cycled it several times. So we put the other flanges, the other 27 flanges, through the same sorts of things that caused the leak on this particular flange. And so we feel fairly confident that we won't have leaks in the other flanges. And if we had a leak, it might be a very small one. So that's sort of our primary flight rationale on the other flanges.
Thank you. Our next question comes from Micah Maidenberg from the Wall Street Journal.
Thanks, Stephanie. Hey, Steve and Mark, you both previously talked about how you believe Starliner was ready for that May 6th flight. And then the leak, the design vulnerability weren't discussed sort of in the run-up to May 6th. Is there something missing in the readiness analysis? And are you concerned, that these issues weren't ID'd, sooner? Thanks.
If there was something missed in the readiness analysis, the capsule would be up at the ISS leaking helium right now. Just saying.
The
just putting it out there.
Issues or hardware failures are just part of our business. They're going to occur as we do launch preps. They're going to occur in
Tone
flight.
deaf, bro.
There's
Tone
no
deaf.
human-rated vehicle that doesn't experience this kind of anomaly. And the important thing is how do you react to it and how do you learn from it?
Bingo.
And I think that's what
Fricks.
You've
This
heard
guy
today.
You're this guy?
How we've done that.
That guy Fricks.
So no, I'm not.
He knows how to
concerned with
space.
our process that leads up to this. We have multiple redundancies in our system. Like Steve talked, we have a case here which was extremely remote that we missed, and if there are more out there, they're going to be in that same category of extremely remote.
And I just added, this is a test flight, and we're gaining experience with this vehicle, and I think our space shuttle experience would say almost in some respect all 135 flights were test flights because we learned something on every single one of those flights. This is like STS-1, the first shuttle flight in some respects of a new vehicle, and so I think we're still learning. This particular leak, I don't think implicates the design of the seal or the flange. It's just maybe a defective part. I go back to my shuttle experience where we had at times leaking helium regulators and things like that we had to manage. And in cases we actually lifted off with some small leaks in the helium regulators that we could manage in flight. So it's a tough system. This is a high pressure system, and helium's a very small, tiny molecule, and it tends to leak. We can look at our Artemis experience with another tiny molecule, hydrogen, and they have had lots of struggles with leaks as well. But I think we understand this leak, and then I think we understand the rest of the vehicle. We got to see the vehicle as it powered up, we got to see the vehicle on the pad and understand how it was performing. And, we don't have any concerns for any other areas at this point.
Actually, Gino, I think that, I don't think that Boeing is doing bad analysis here in this regard. I think they're doing really good analysis, but they also are getting an enema from NASA to make sure that the analysis is good, figuratively. An enema from NASA, yeah. So that's
Steve or maybe Mark, and it's really a follow-up to Mark's question.
It's actually some pretty damn good analysis and design going on here, and this is what you want to do during a crew flight test. Test being the operative word. Steve Stitch just said a second ago. I'll pause for a second. Steve Stitch, who he was a flight controller in the shuttle program for a long time, 37 years. He's worked in spaceflight. He was saying the reason why I cringed at him saying, "Oh, we learn something every time with the shuttle program," is because. Look, man, he said, every test with the shuttle, every flight with the shuttle was a test. That is not how you conduct operational spaceflight. That's bad. You don't want to learn new things during operational missions. That's why I was like, ugh, when he said that. But the flip side of that is that, you're always going to learn something new. Spaceflight is just, it's just such a high factor of difficulty. You do always learn something new. Ideally, what you want to be learning is more like what SpaceX is doing, where you're expanding the flight envelope of your vehicle. Learning about hardware faults 130 plus flights into the program that's bad. That's not the flex you think it is, man. That's all these teething problems from the entire shuttle program. Those should have been solved in the 80s, but they weren't, because we did 4 test flights on the most complicated vehicle ever designed and then called it a day. Now, a capsule like this one, not nearly as complicated. However, you still don't want to learn new things during operational missions with the hardware. The hardware should be well understood by the time you're going to put people on this for routine flights. Now, with that being said, you can't think of everything. There's always going to be an unknown. We learned new things about the Apollo capsule when we were flying it out to the moon 50 years ago. Like if you drop the oxygen tanks on the ground and then put it in and hope everything's fine, and they go to stir the tanks and run an electric signal into an oxidizer tank to stir a tank, and the Teflon seal's cracked because some moron dropped it, and you get an electrical arc through an oxidizer tank that heats everything up and blows the tank up on the spacecraft mid-flight. Yeah, probably shouldn't do that. Probably shouldn't do that. You probably shouldn't drop the thing before you put it in the spaceship. Yeah, it's probably not good for it. But the point is that we still learn new things with the Apollo capsule, all the way, even until the last mission. That's not necessarily how it should be. I think that this is something that SpaceX has on lockdown. Their high frequency of flight affords them to be able to, to get all the hardware bugs and defects out of the design because of high frequency of flight. And then, like with Falcon 9 right now, it is just straight up expanding the flight envelope, because that the behavior of this hardware is well understood and corrected. Now, all that being said, this is the time during a crew flight test where you want to find these problems. You want to do the analysis. You want to get it right, because you're putting people on it. Don't roll the dice like that. Any problems with commercial crew, even at this point, would be catastrophically bad for NASA, Boeing, just space flight as a whole. Catastrophically bad. I appreciate Boeing and NASA doing their due diligence and doing good failure analysis here to make sure that this doesn't happen. It's totally fine to lose a capsule door mid-re-entry, right? It's a test flight. That behavior probably is not something you want. You've probably figured that one out. So, with that being said, I really appreciate the analysis here. It's quite good. They've done a good job. It seems like, honestly, somebody just over-torqued a valve. Over-torqued the flange for that helium valve. That's honestly what happened. I'm pretty damn sure. Yeah.
Because that just differs a bit from what I'd initially heard. And then second, if I could just get an update on
Let me just rewind this question.
Hi, this question is for Steve or maybe Mark, and it's really a follow-up to Marsh's question. I just want to be crystal clear here. that there was zero discussion of a helium leak before the decision to scrub, and I asked because that just differs a bit from what I'd initially heard. And then second, if I could just get an update on the crew, when they'll come back to the Cape, that sort of stuff. Thanks.
Oh, yeah, that sort of stuff.
Hey, Steve, I think you've said it. I'll try it as well. I sat, and both Steve and I were in the control rooms for the launch countdown, and it wasn't until the scrub activities, post-scrub activities, that we discovered this leak. So it was not talked about or seen until the post-scrub activities. And the latest that we have on the crew, Steve, you can check me here, but the latest we had on the crew was that they were going to be flying to Florida on the 28th.
Yeah, that's what I have as well, Mark. I think they're flying down. They usually travel about 4 days prior to launch, and I think they're traveling on the 28th, the day before the agency Delta agency FTRR.
Yep.
Okay, thank you. Next up is Lauren Grush with Bloomberg.
Hi, thank you so much. Sorry if I missed this, but I'd like to expand on what I think Mark spoke about regarding metal-to-metal contact of the seal where the helium leak is just to fully blow. So can you just explain what that would mean and how you would manage that? And I also remember there were some issues with a few thrusters on Starliner during the uncrewed test flight back in 2022. I just want to know if this helium leak and or the deorbit burn redundancy problem are related to those issues. Thanks.
All right, so I'll try this, and then Steve, you can jump
Yeah,
in.
Hibbett, sure.
Here for the OFT1 activities. I don't believe those were related in any way to what we're talking about today. And when I was referencing the metal
analysis rocket
on the flange, what we did was we said we wanted to understand the leak rate, and if it was to get worse, what could we tolerate? So some testing was done, and analysis backed it up, that if we were to remove the seal completely and just torque the flange down, the leak rate would not exceed our capability to manage that leak. So that made us very comfortable that if this leak was to get worse, it would be acceptable for flight. Steve, over to you.
Yeah, thanks, Mark. Yeah, on Starliner 1, we had some RCS thrusters fail off. Now, those turned out to not be real thruster failures. Those were essentially the software in the integrated propulsion controller failed off a totally good thruster. And so we've made some changes in the software and the firmware to go fix that, and so we shouldn't have those happen again. And we actually recovered those RCS thrusters. We did have two OMAC thrusters that failed off right during the orbit insertion burn on OFT1. We went and ran the potential failure mode for those down. Again, as Mark said, we don't get the hardware back, unfortunately, in the service module because it gets disposed of in the ocean. But the likely cause of those, based on the signature and data that we saw, was some sort of blockage that perhaps was in that manifold and on the fuel or oxide up to that thruster. And so we went and did extensive borescoping and cleaning and making sure that we didn't have any kind of the FOD that might have been present. Did extra checks on the vehicle. So we don't think we're going to have the OMAC issue we saw in OFT1. And that gives us confidence in going to fly with this small helium leak.
Hey, yes, what's going on?
Thank you. Next up is Stephen Clark with Ars Technica.
Hi, thank you. I think my question's probably for Mark or Steve. Just a question on the seal. Apologies if I missed this earlier. Can you talk about what the seal is made of and how big the dimensions of the seal? And what would, if you elected to replace the seal to, resolve this leak, with a hardware solution, what would that entail? Would you have to bring the spacecraft back to the C3PF to do that?
Yeah, let me talk material for the seal. I can get the details. It's basically a rubber seal.
Just an O-ring.
Think of it as a ring, almost like you would have in your faucet in your sink if you do your own plumbing work. The size of it, it's pretty small.
I do my own plumbing.
Have a button-down shirt on like I do. It's roughly the diameter of the button on your shirt, so it's pretty small. And then the thickness of it, it's about the thickness of it's pretty thin. We would call it a 40,000th of an inch. And if you took 10 sheets of paper and stacked those together, that's how thin this seal is. And so that is why we likely think, because it is such a thin seal in terms of thickness, that maybe there's a little defect in it. That's the most likely failure mode. When we talk to the vendor, they have used this particular seal in other applications and have seen, good reliability from it. We saw good reliability on OFT1 and also OFT2 as well with these particular seals. So that gives us some confidence in it. And then I did misspeak. I think the failures I talked about, I think I said OFT1 by mistake on the thrusters, the RCS thrusters and the OMACs, and it was really OFT2. And I'll let Mark talk about what we'd have to do if we were to go.
Yeah, it's a little tiny boy.
Repair the leak.
They're going to have to detank the capsule.
We did look
They're going
at
to do that.
What
That
it
would suck.
take to go ahead and change this seal out. And so the key piece is that this is in the hyper system, the MMH fuel and N2O oxidizer.
Yeah, you need that not to be there.
Is in that flange. So we characterize that as a hot system. It's hazardous to go do that work. We would not be able to do that work out at the VIF, so the vehicle would need to be destacked, brought back to the C3PF, safe in one way or the other, which would most likely involve deservicing the vehicle and then going in an escape operation and changing the seal out. So it'd be quite involved.
Thank you for that. Will Robinson-Smith is next up with Spaceflight Now.
Yes, hi. So much for taking the time to answer our questions, and apologies, I'm fighting a cold, so hopefully my audio comes through clearly. Question for Steve as far as the timing of the mission, and maybe for Mark as well. You mentioned that there may be some alterations to the deorbit burn should the need arise. In the ascent and going into docking, as Butch and Sunny are doing some of the manual checkouts of Starliner, are there any thoughts to change the timeline or some of the manual operations that they're going to be doing? Can you just go into a little more detail on what that may look like? Thanks.
Yeah, this is Steve. Right now, we don't envision any change to the flight plan relative to any of the crew manual flying objectives that they plan to do, or any of the rendezvous. As Dana said, that we've looked at the rendezvous profile. We've looked at redundancy. We don't see any issues relative to this particular doghouse leak. And I want to clarify the change at the end of the flight. We nominally plan to do the deorbit burn just the way we have on OFT1 and OFT2. We plan to do an OMAC burn. We have redundancy, and we can handle an OMAC failure and still execute the deorbit burn. It would be in this pretty remote case where we lost the helium manifold totally in two different doghouses. So, and as Mark said, in the port doghouse, if the leak rate were to increase, we can feed that leak. We have the way to see what that leak rate is during real time, even on the way to station if that leak rate's increasing. We could always isolate that doghouse temporarily, preserve helium, and then reopen it for critical burns or critical parts of the approach to ISS.
Yep.
So we have lots of options to manage that. And then the nominal plan is to execute the mission as advertised, as we've planned for many years. And again, the deorbit burn will be with OMACs, just like
those are the doghouses right there. See that? These things?
That we would have
It's
to
the component that houses the thruster block.
2 burns with the 4 RCS jets.
This thing.
And I do hope you feel better.
Oh, that's cool. See that? That's
Okay,
the doghouse
next
covers
is
up the
Marina
thruster.
Koren from the Atlantic.
See right there?
Hi, a question for Mark. Before May 6th, your estimate for the probability of loss of crew for this mission was 1 in 295. Given the issues that have come up since, where does that ratio stand today? And a real quick question for Jim. You mentioned that part of the delay for giving us public updates is because you said we're moving pretty quick. Why? Why? What is driving that pace? And is there a reason you're not wanting to slow down as you work through these problems and even destack the vehicle to reach that seal? Thank you.
They just answered that, lady.
So our,
they literally just, that was the last question.
To this as well.
That's what they just stopped talking
our
about.
Risk posture, our probability is not related to this area at all. It's related to a different cause. So no, this does not affect that at all.
Oh my goodness.
Yeah, I would agree, Mark. Yeah, go ahead, Jim.
I would say the information was flowing really quick. We're moving quick to address the issues. Steve and his team and Mark and their teams were meeting every day, doing analysis, getting new information. They've shared with you kind of how some of this progressed, and we're never moving too quick that we're compromising safety. We're moving quick to get the information, do the analysis.
Yeah, what I do.
And
they will.
And get to flight, but we're not going to fly until we're sure we're safe.
Dude, look, man, I understand people don't understand this stuff.
Thanks, Jim.
This stuff is really complicated.
Next up is Anthony Leone from Spectrum News.
This stuff is really complicated, and it is difficult to understand. It really is. I've been trying to figure this out for years, and only I've been streaming and learning about spaceflight for better part of a decade. I really only got a good grasp on it probably in the last 2 to 3 years of how everything works and the mentality needed to do this correctly. That was after 8 years of struggling, in KSP, reading about this stuff, understanding how it works, but the most important thing was understanding the mentality. Like why you would do this way. Where is single fault redundancy a good idea? Why would single fault redundancy be a good idea as opposed to double fault redundancy, like 2 fault redundancy in a spacecraft, and how this risk aversion and management gets implemented at a systematic level. Basically, why did this part fail? Why did it fail? How did this happen? Stuff like that. Figuring out the mentality for it took me a long time. With that being said, look, man, if you're not going to listen to the teleconference and just wait for your question to ask and then ask a question that literally just got answered, how interested are you in this? Is this just your job? Is this your day job? Like, I get it. I understand. But, honestly, there's easier things to be a journalist about. Honestly, I'm not trying to gatekeep or anything, right? I'm not trying to gatekeep or anything, but do you even care? That question was just answered a second ago. Are you serious? They just talked about this a moment ago. It's so hard to understand these things without doing them. And that's the gap I try to bridge here, Fish. Look, man, I understand that people want to just do this as the day job, right? But there's asking a question because, you're generally interested in, you don't even need to be interested in space, you're generally interested about the journalism behind this stuff. And then there's just blatantly not paying attention. There's people that I see there's journalists at these media teleconferences that are just there because their boss said, you need to be at this teleconference to get information. It seems that some of these folks don't care. They don't care, because if you care, you would have been listening instead of being on Instagram and then waiting for your turn to speak, or whatever you were doing, answering emails or whatever. Now, granted, I answered an email during this press conference, but I understand the source material and I understand what went wrong, and I was listening while that was going on. Did you guys even notice that I answered an email? Nobody noticed, and I was still able to convey the source material here. That took a long time to cultivate, and I understand this does take a long time, but geez, man, listen. It just drives me up the wall, man. Are you guys just here for a paycheck? Do you even care? Do you even care about writing a good story? That's your job. I guess I just don't understand that, you know what I'm saying? Perhaps you needed to ask it for their news service. Yeah, Christoph, I always have to remember that too. Some people don't care about space as much as I do, and that's fair. I'm a little bit obsessive with it. I get that. I understand. And also, sometimes people ask these questions to get on the record. You know, say, well, I asked the journalist this question, and this is what they said. But, like, to imply, like, loss of crew stat in a very, very, very isolated fault tree analysis tells me you know nothing about spaceflight. You're just there. That is an instant giveaway that you don't know what you're talking about. Has the loss of crew probability increased for this helium leak? They've literally spent this entire press conference saying that this is a very minor issue. And had the chattering valve on Centaur not been chattering, the spacecraft would be up there right now. And they would have isolated this problem on the ISS, and they would have figured out a contingency procedure for EDL, for entry, descent, and landing. They've said this. Like, this is the subject matter of the entire interview. Are you even listening? Like, changing probability of loss of crew isn't the question. Like, that is not even remotely close to the subject matter being discussed here. That's like us talking about engines on a car. Like, oh yeah, the engine has the piston that goes up and down. And somebody asks, yeah, but what about the tires? What about the tires? Well, the engine is connected to the tires, so it could affect the tires. We're not talking about the tires. We're talking about the engine. I mean, yeah, you're right. We're talking about the engine. Yeah, but the tires, though. What? Like, you see what I mean? It right there, it tells me you're just asking a question to ask a question to get on the record. There's, oh, well, nobody's asked about loss of crew. Maybe there's a reason why. Like, that's what I'm getting at. And, like, once again, I'm not trying to gatekeep. I'm not trying to be a douchebag about this. Like, I understand not everybody's going to know. This stuff takes time to understand. With that being said, I guess the disconnect here is just me not understanding why you wouldn't want to put the effort in here. Like, even to write a good story or to write a good report. Like, it's very weird to me. Like, that's a foreign concept to me. The concept of not putting, like, effort in for your work really is something I don't really understand. Like, my mind has trouble with it. With that being said, I understand people go to work and they just do what's good enough. I get it. I do understand that, But, yeah, it's just strange. That's a strange line of questioning. It's not really relevant to subject matter. Someone that works on the technical side of things, where people do often care about the work, I've realized most of my business side partners are just there for their paycheck. Not a bad thing. Work is work, but it's true. Johnny, I don't know, man. I guess I have trouble understanding that as somebody that loves spaceflight. I am horribly biased towards, like, any type of spaceflight. Like, just horribly biased. Like, frick you, we should go further. We should be on the moon. We should be on Mars. We should be on Jupiter. I don't care. Yeah, I said it. Gas giant. Let's go. Figure it out. Like, I know that doesn't make a lot of sense, but okay, we'll go with the Jovian moons. All right, Io, Ganymede. Let's go. We should be there right now. Come on, we were on the moon 50 years ago. We should be out in the outer rim. We should have a base on Pluto right now. It's ridiculous. I guess it's just something that's so ridiculously important to me. I guess I get a little annoyed when people don't take it seriously. You know what I mean? Find the monoliths, damn it. You're right. Cloud City, let's go. But anyway, sorry, rant over. I'll shut up.
Hello, everyone. Thank you for taking our questions today. This one is for Steve. So just to recap, we're going to launch, even though there's a leak. So my question is, how confident are you that this issue that has caused the leak because of the seal in the thruster control system, are you confident that won't worsen during the launch vibration, plus being in orbit and then re-entry? I know you're talking about that, but it sounds like there's definitely some concern if you guys are thinking of backup plans. Thank you.
Okay, okay. All right, here. This guy just might be understanding. He might just be asking this question to understand, and that's fair. But this is the stretch that took me so long to figure out, and it takes everybody a long time to figure this out. There's a reason why you got to go to school for a very long period of time to be an aerospace engineer or any type of engineer. It's very stringent. The courses are extremely hard. It will fry your brain. I haven't even taken engineering courses. I know that. I've talked to enough people to know it's like boot camp for your mind. Okay? Now, with that being said, he's asking about, well, if you know it's leaking, why are you going to launch? And what's your plan when it does leak on orbit? There was a reason they discussed contingency plans a second ago. They were discussing potential contingency plans for this leak, and the biggest reason, here's the biggest one. The biggest one. This is a very, 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 very isolated failure mode. In plain English, it's not that big of a deal. The plain English way of saying this, even, and NASA won't say this, they won't say it. But look at the doghouse. See that? There's a lot of thrusters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In each doghouse, there's a lot of thrusters. There's a ton of redundancy here on purpose. The reason why there's a lot of thrusters is because these are shuttle thrusters that have been fitted. They're shuttle RCS, the vernier thrusters from the shuttle, and the shuttle main reaction control system components. That's all shuttle stuff right there. That's why. They reused a bunch of shuttle parts. Not the actual pieces. They're new, but the same components. There's a lot of extra thrusters on this thing. There's enough redundancy that makes this an extremely isolated failure mode. The reason why they delayed in the first place is to verify that helium leak is there and understand it on the ground, because it's easier to understand it on the ground when you can put hands on the spacecraft rather than it orbiting around up in space and not being able to see your service module. See what I mean? This is what I mean about the mentality. He said, "Oh, well, do you have a contingency plan for when it launches and when it leaks?" Yeah, of course. But they wouldn't have figured out that contingency plan if they hadn't discovered the leak in the first place. See what I mean? It's very, very cold, logical thinking. It's really hard to wrap your mind around this if you're not like super into it. It takes a ton of time. Look, they hadn't found this helium leak. They would have sent it. They would have discovered it on orbit when the Starliner docked, and they went through the same safing procedure for the thrusters. They would have found it. And then they would have come up with a contingency procedure while the capsule was up on the ISS. And then it would have landed. It would have landed just with a 2-part deorbit burn instead of a single part. Steve Stitch said that. Okay? Now, at the end of the day, guys, this isn't a big deal. The reason why it's being delayed is just so they could take the time to understand the behavior, because it's easier to do it down here than it is up there. Starliner could launch right now. It's really not a problem. There's a lot of thrusters on it. And once again, that's the plain English way of saying it. The more complicated way of saying it is that this is a super isolated failure mode. But they only figured out that it was a super isolated failure mode because of the analysis that was chosen to be done that delayed Starliner. See what I mean? It's kind of a weird, like, backwards, roundabout way of thinking, you know? And that guy might just be trying to learn, the guy that asked this question. That's fair. I understand that everybody's at different levels of learning, right? But I guarantee you what they're going to say here is that this is an isolated fault. It's not that big of a deal. The reason why is it delayed isn't because that they're going to do anything about it. It just gives them time to understand the capsule better. And now is the time to do that. You do that down here so you don't, because it's harder to do it up there. You don't want to fail up there, right? Even for a small issue like this, it's good to get a good baseline and understand the behavior. You know what I mean? That's very, 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 very important. But they wouldn't have found it if they weren't anal retentive about figuring out this stuff. That's what I mean about doing good analysis. So yeah, they do have a contingency plan. They would have had a contingency plan even if they had launched it on the 6th. It really wouldn't have been a big deal. This is not that big of a problem. It's so much that it's not even that big of a problem that they're not even going to replace the valve. They're just going to understand the behavior and adapt the mission profile for it. Now, the reason why they're going to do that is, once again, because getting a good baseline with your crew flight test is really important. But here's the thing. Deintegrating the capsule right here, taking the capsule apart, safing the capsule, bringing it back to the Starliner processing facility, replacing that valve, sending it back to fueling, refueling the capsule, and then restacking the capsule is enough of a deviance there that it's actually a better baseline just to leave it there with the leak Think about all the extra stuff that you have to do to that. That's affecting your baseline, right? Because not every Starliner is going to be stacked, get ready to launch, scrub, be taken apart, unfueled, refueled, put back on the pad, and launched again. Future missions are not going to do that. So it would be better to get a baseline here because this is such a tiny, tiny thing. It would be better just to not do that, just to deal with the leak. That's what I mean. I know it sounds super counterintuitive, but that is a better bench test than taking apart the valve, sending the capsule back to processing, taking the thing apart, putting it back together, and sending it. That actually would be a worse baseline because you're not going to do that with every capsule in the future. So you wouldn't think of that, right? It's weird. It's a weird way of thinking, but that's what I mean about wrapping your head around this stuff. It's a very, very peculiar way of thinking about these problems. It adds way more risk, Ninjax. Exactly. That's way more. Dude, taking the capsule apart at this point, that's way more dangerous than just living with that helium leak. That's what they're trying to say, but sometimes NASA has trouble trying to say it in plain English. Sometimes they're good at that, sometimes they're not. It depends on the questions that the journalists ask. Anyway, yeah. Trying to replace that valve would undo months of baselining work. If they decided to take apart that thing right now, Starliner would not launch till the end of the year. It's better to just live with the leak. That's a better bench test than trying to replace it. As long as they're confident that they know why that valve is leaking, then it's not a problem. You know, and I know what people, I can already see it now. I know what journalists are going to spin this into. Boeing is going to launch with a leaky valve? They're going to launch with a leaky valve. They knew about the leaky valve. What kind of failures could this lead to? And we already saw a journalist ask that question. What's the probability increase of loss of crew? See? That's the wrong way to think about it. That's not how you spaceflight. That is not correct. That is not the right mentality for understanding spaceflight. You got to go backwards. You got to think about it like backwards instead of forwards. See what I mean? This is hard to understand, man. It's so difficult. I still get it wrong. I've been doing this for a decade. I still get it wrong from time to time. The process of fault management. Yep. Yeah, exactly. Boeing went through this flow chart here. There you go, Rocky. I'll link it up. They went through this flow chart with that valve right there. Now, if you don't know what some of these words mean, that's fair. To be honest, I don't know what some of these words mean, but I know this is fault management. Can you explain the backwards, not forwards part? Sure. Okay. All right. ASAB, let me try to put it to you in plain English, okay? So, after the scrub on May 6th, they were shutting down the thruster systems. You have to prime these thruster systems. Now, what do you mean? How do you prime these things? Well, all of the thrusters, the reaction control systems, the little tiny thrusters that are used for maneuvering around in space, right? You're not going to need a gigantic freaking rocket engine up there when you're going to dock to a space station. That's way too much power. You got to make little tiny, simple maneuvers to get to a docking port and dock to the ISS, right? So you got to have little thrusters. These thrusters are called reaction control systems, or RCS for short. Starliner has what are called thruster blocks, okay? 1, 2, 3, and 4. They're at 12, 3, 6, and 9. These things are called doghouses. Inside of one of those doghouses, on one thruster, on one of those doghouses, the thrusters are pneumatically actuated. So what these thrusters do, they're little rocket engines. That's what they are. They're little tiny rocket engines that maybe, I don't know, the diameter of the nozzle is about the size of a golf ball maybe. They're really, really small. Now, what do these thrusters do? How are they fueled and how are they actuated? I said that it's a pressure-fed system. So equal and opposite reactions. Up in space, you don't need a lot of thrust to move, right? You're going fast enough where you're falling around Earth, so you don't need much reaction mass to move in a certain direction. So these guys, that's why these guys are really, really small. Also, you need to do precision maneuvers to get to a docking port, right? Now, how do they work? They're helium actuated. So what are they doing? Are they just shooting helium out the capsule? No. That's very inefficient. It'd work, but it's very inefficient. What that helium does in these thrusters right here is actuate valves that shoot rocket fuel and oxidizer into these things. In order to make combustion, in order to make an explosion, you need fuel, air, and you need heat. Okay? Now, the fuel on these thrusters, okay, is monomethyl hydrazine and nitrogen tetroxide, MMH and NTO. All right? So, take this into account. I'm getting to the backwards thinking part, ASAP. Just give me a second. Take this into account. NTO and MMH, you touch it, you die. It's that simple. It's very good as a spacecraft propellant on orbit because even in the vacuum, NTO and MMH, because they're some weird chemicals, monomethyl hydrazine and nitrogen tetroxide, they stay liquid. They don't boil off. They don't decompose. They just stay there because it's some chemical from hell. And if you touch it, you die. Okay, take that into account. Remember that, all right? Because that very much plays into this, okay? Now, helium opens up solenoids here. Solenoids are just valves that open and close. You have solenoids on your car if you have an internal combustion engine. Fuel injectors are an electronically actuated solenoid. An electric signal gets sent, the solenoid valve opens, fuel gets sprayed into your engine, solenoid valve closed when the electrical signal stops. That's an electrically actuated solenoid. These are pneumatically actuated solenoid. Now, why pneumatics? Why use pneumatics? Well, generally, you don't really want electrical stuff being near the rocket engine, the thing that explodes. Electricity generates heat. Heat makes things pop in the right conditions. So they're using pneumatics. They have a pneumatic opening valve with inert gas. Helium's non-reactive. So helium gets pressurized to these valves, and helium, when they have increased pressure in the valve opens, sprays NTO and MMH into the rocket motor, those things, the propellants that can kill you, right? If you breathe them. It sprays that into the rocket motor, and when MMH and NTO chemically combine, they explode. The chemical reaction that you get from mixing MMH and NTO generates an insane amount of heat and makes combustion. It's called a hypergolic propellant, okay? So very good for a spacecraft, very good for spacecraft fuel. It lasts an insanely long time on orbit, so you're going to anchor this capsule at the ISS. You can't have your fuel decompose over time. That does happen with other capsules. Soyuz, for instance, uses an ammonia thruster system, and ammonia will decompose over time up in space. So the capsule has a shelf life. You have a much longer shelf life with NTH and MMO. NTO and MMH, sorry. So, okay, so those propellants, pressure fed. Helium controls the valves that open and close here, okay? Helium also pressurizes the propellants so the propellants squirt into the it also back pressurizes the system, so NTO and MMH are under pressure and get sprayed into the nozzle. But that's not the part that failed here. The part that's really weird is the pneumatic system going to the actuator, so the thing that opens and closes. Okay. All right. So now you know NTO and MMH bad for you. These systems pneumatically actuated, so they're using pneumatic valves. That's a pneumatic valve controller right there. I'm pretty damn sure that has all the valve actuations and all the hard lines going to all the valves. See that? Also, the cable management is ace on that. That's very, very, very aesthetically pleasing to look at. But see all these metal lines in here? Those are your pneumatically actuated valves, right? And that's most likely your valve controller right there. I'm taking a guess. I don't know. I'm taking a guess, but what I know about hardware, that seems right. So, all right, why? Okay, so you go to safe the capsule after the Centaur has a malfunction, okay? You go to safe the capsule. When they safe the capsule, part of it is depressurizing the valve actuators, because when the thing launches, you're going to need these. After you get into space, you're going to need that. You ideally want them ready to go when the capsule separates from the upper stage. So they begin safing. Now, what's safing? My lawnmower's on. Now, what's safing? My father-in-law wanted to use the ride-on mower. So if you hear the lawnmower in the background, that's what's going on. So They went to safe these systems, okay? And they discovered that one of those lines going to the actuator that delivers fuel, that controls the valve that delivers fuel into the rocket engine, was leaking. They did that because they shut them down in series. They don't shut them all down at the same time. They shut down 1, shut down 2, shut down 3, shut down 4. You got to bring the pressure down in the lines, right? And because while they were shutting down all the valve actuators, right, they found one. They went to shut it down, and the pressure dropped really, really fast comparatively to the other ones. You would see that in the telemetry from mission control. The guys that are, the guys that wear the black ties and thick rimmed glasses in the flight control room, they would see that on the telemetry and see the helium level went down faster on this one than the other ones. Okay, so you might have a leak here. So you might have a leak, right? He wanted to use the ride-on mower. He thought it was cool, so I let him use it. I gave him the cliff notes on how to use it. It doesn't sound like it's going very well, but he'll figure it out. So, they figured out that there's a leak. Now, here's the thing. Okay, you have a leak on 1 out of the 27 valves that are on this thing. You have a leak on 1 of them. So now what do? You look at that. You see it drains hydrogen more than drains helium more than the other one. Now what? Okay, well, let's make sure that the other ones work correctly. So, they probably went and repressurized all the other ones and then flip them on and flip them back off. Very simple stuff, right? And they figured out everything else is working just fine. The rate of helium depressurization is fine comparatively to that 1 out of 27. So, okay, here's the thing. You have 1 out of 27. Do you think it's a hardware problem? No, it's probably not. If 1 out of 27 valves is malfunctioning, it's probably an isolated incident, right? So right there, they probably figured out on the first day, right, that this is 1 in 27, not a big deal. There's redundant thrusters all over the place on Starliner because it's borrowing a bunch of shuttle thrusters for its service module. So there's also multiple redundant thrusters pointing in the same direction for this exact reason. See how there's 2 of them right there, and then there's 3 of these right here? And Starliner has 4 of these housings. There's redundant thrusters all over the place. Redundant thrusters is smart, very smart. Shuttle did that, very good design. Now, okay, so they figured out on the first day that this is a very isolated incident. And if it does leak, it's not that big of a deal. But here's the thing. You have some downtime. They have to change the valve. The original thing that scrubbed the mission, they got to change the valve on Centaur anyway. So there's going to be some downtime where the capsule's inside of the hangar, while they're replacing the valve. So you might as well figure out exactly what's going on. That was the original reason why they delayed it. So when it went from the 17th to the 25th, when it scrubbed on the 6th, they said it'll launch on May 17th. That is the time it took to change the valve on Centaur. And while that was going on, Boeing also did some fault tree analysis, right? They went back and made sure that what they saw in mission control the day that it scrubbed is actually what's going on, and it was. Okay, so because of this, right? And this is where the backwards thinking comes into play. They verified that that thing is leaking. It's leaking pretty bad. It could get, at full pressurization, it can get up to 50 psi a minute. That's hissing. You'd hear that. You would absolutely hear the sss, right? Now, remember how I told you that NTO and MMH are very, 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 very hazardous. You breathe like 1 ppm, that's it. You game over. You lose. Either one of them. Okay, so think about this for a second. Boeing verified that that valve is good to go, right? And here's where the backwards thinking comes into play, okay? So they know you understand that that helium valve is not working. Now, if you wanted to replace this helium valve, it's attached to a hot system, meaning it's fueled. You don't just go at it with a wrench on a hypergolic system no suit, no hazmat, no nothing, and start wrenching around. If you accidentally make a leak and the guy breathes in MMO or NTH, dead. It's not even a judgment call. This stuff is terrible for you. Like nerve gas bad, not good. Right? So, here's the backwards thinking. What do? To replace this one valve that's in 27, not 27 times redundant. It's not. The thrusters, there's 27 thrusters in the system. They're all pointing in different directions. At the very least, it's 1/8 redundant. So there's 8 fault redundancy in the thrusters. That was implemented by design because they wanted to reuse shuttle thrusters because propulsion research is a pain in the butt. Making new rocket engines is annoying. Why would you do that unless you absolutely needed to? Case in point, let's take Falcon 9. Falcon 9 required an engine that had never existed before to come back down and land. So that's when propulsion research was warranted. But even Falcon 9's Merlin engines are about as simple as you can get for a gas generator Carolox engine. They're very simple. Long story short, redesigning thrusters takes time. That's the most important part. If the thruster doesn't work, you're not spacing today. Right? Now, what do you think would be an easier route? Because remember, the whole purpose of this is to get a good baseline. That's what this crew flight test is about. You want to get a good baseline. The crew flight test is supposed to represent the idealized processing flow of what a future operational mission is supposed to be like. Ideally, you don't want to learn anything, but sometimes you're going to. That's just the nature of the business. All right. What you do with that information, with that newly learned information, separates separates like what SpaceX does from any other company, right? How you process and how you understand that information is important. Here's the key. Okay? So, you know that thing is malfunctioning, you know the rate at which it's malfunctioning, you understand that. That is attached to a fuel system that is very, very volatile. So what do? Say you want to replace that thruster, okay? Remember, keep in mind, ideal baseline mission. What's the ideal baseline? You stack the capsule together once, you roll it out to the pad, send it, and it works perfectly, right? That's your ideal. Now, here's where the backwards thinking comes in. I'm getting to it, I swear. This is complicated stuff, and that's why I'm talking slow, all right? Now, keeping in mind that you're trying to get the closest baseline you possibly can to what an ideal mission looks like, which one of these scenarios better mimics that? If you roll with the valve that is at least 8 fault redundant because there's other thrusters, right? And B, you understand the rate of leak, right? Because of those two, you send it, you deal with the leak on orbit. Or B, you want to replace that valve to get a better baseline. Okay, doing that, you got to unstack the capsule, take the capsule off the service module, send the service module to a special refueling area because it's not like a gas station. You can't just put the gas in and be set to jet. There's a special fueling depot at the Cape where they fuel spacecraft with these hypergolic propellants. It looks like something out of a sci-fi movie. There's guys in spacesuits. They're actually they're called scape suits. Scape suits it looks like a spacesuit. It basically is for all intents and purposes because you do not want to breathe this stuff. It is a 100% confined suit, no leaks, and you have a personal oxygen pack. It's like scuba diver and a spaceman kind of combined. SCAPE, scape suits, if anybody's wondering. So now you got to take the capsule off. You got to take the service module. You got to take the capsule off the service module. You got to send the service module back to the fueling depot, right? They have to take all the fuel out, and then you have to take the service module, bring it back to the factory, which is at the Cape. It's by the VAB. It's in one of the shuttle orbital processing facilities. It's called the C3PF, Commercial Crew Cargo Processing Facility, C3PF. You got to take it back to the C3PF. You have to undo the work. Just because that valve is malfunctioning doesn't mean you're gonna, it's just one wrench. Let's just take it apart. You might have to take apart other things here, right? And those other things, after you take them apart and put them back together, that all has to be documented. All right? Now that you took this apart, some of these things are only designed to be attached once. You might have to replace some of this stuff. right? The service module is only designed for one use. It's not reusable. So some of this, because of that, might be something that, like a nut or a bolt or something. It should only be torqued once and stretch the nut once, right? You might even have to, so you have to replace the valve, you have to replace the seals, you have to replace the flanges, and who knows what you have to take apart in that freaking mess to get at that valve, right? You have to do all that. You have to hope that that goes right. It probably would be fine. Now you put the capsule back together, put the service module back together, put the capsule back on, send it back to fuel, send it back to the launch site. That'll take months to get that right, because fueling these things takes time, and it's a very slow process. It takes about a week, because you don't want to you want to slow fill these things because it takes time. Now, once again, you do all that, or you live with the crappy helium thruster and you deal with it in space because you have redundant thrusters. Which one of these options seems like a better bench test? This is where it gets a little backwards. I'll tell you. This one. This one is the right call. Absolutely the right call. Because an idealized baseline mission doesn't involve sending the capsule to the pad and then sending it back, taking it apart, putting it back together, and then putting it back on the pad. That's not ideal. That's not the idealized mission that the crew flight test is aiming to accomplish. Long story short, it's better to live with the leak. And that's where that kind of backwards mentality comes from. Honestly, that's pretty damn good risk assessment on Boeing and NASA's part. It really is. That's really smart. Do you want to go take that whole thing apart? Who knows? Maybe somebody goes to take it apart and breaks another thing, and then your capsule's screwed even more. It's better to live with the leak that's well understood. It's better to live with it. Does that make sense? And I know that seems backwards. That seems like, what? Are you crazy? It's leaking. What are you, dumb? But that's what I mean about thinking this way versus thinking that way. You gotta go back to it. You gotta understand all the components involved and understand how much of a pain in the butt it actually would be to go and replace that valve. You would be introducing so many variables into the processing flow. The processing flow is basically putting the capsule together, stacking it, making sure it's good, going to fueling, stacking it on the rocket, getting crew on board and getting it ready to go. Screwing with that processing flow, right? By going backwards a couple steps, then going forward a couple steps, right? Is going to introduce more variables than a known and well understood leak. Right? That's what I mean. It seems super counterintuitive, but this is actually a really damn good lesson in risk management. Because, see, if you were thinking safety here, well, we want to be safe. And this is an important lesson on how perceived safety can be actually more dangerous. Okay, this is textbook, right? The safe thing to do would be to replace that valve. But by being safer and replacing that valve, you're introducing more variables into the processing flow of the capsule that wouldn't be there in future test flights. The safe decision here is actually more risky. Weird, right? It's weird, huh? That's what I mean about backwards thinking. ASAP, does that make sense? Sorry, I didn't mean to talk your ear off, but sometimes it's rocket science, man. Sometimes it takes a second, Yeah, Blue, exactly. Plus, when you take apart the rocket, you have parts, launch pad, rocket just sitting for months, which is very bad for unknown unknowns. Yep. Thanks, you made it perfectly clear. That's what I mean. Dude, spaceflight is full of stuff where you have to... Dude, it is full of logic puzzles like that are such a pain in the ass to solve. And sometimes, it's completely backwards. And now, I don't envy the guys in this press conference because they have to sit there and they have to try to explain this to somebody that's like, well, what if you kill people? What if there's an increased probability of people dying? That's what I mean. The person that asked that question does not understand at all the risk management techniques that NASA is using. They're not even making an effort to understand it. That's what pisses me off. Like, NASA has to sit there and try to explain what I just did, like, in 5 minutes. It took me 15, 20 minutes to kind of iron that whole thing out. No, Pigeon, they're not going to replace the valve. Replacing the leaky valve is more risky, believe it or not, than just dealing with a leak that you understand the behavior. Also, Rocky, all spacecraft have a thing called mate demate limitations too. These can only be attached and detached a number of times where you need to replace parts. So that also must be taken into account. So a simple assessment conclusion is the risk of going with the leak is smaller than the risk of replacing. Bingo. I mean, Rocket Guy, I know you understood this, right? See what I'm talking about? That's what I mean. It's backward thinking. It's really hard to wrap your mind around this stuff. But you have to have a damn good knowledge of how the spacecraft works. Like me, I've been sitting here trying to brute force this into my freaking caveman head for a decade, and I still get it wrong from time to time. There's a reason why I don't work for NASA. NASA, if you want, pretty good. And your boy's getting better at this. Anyway, yeah, it's completely counterintuitive thinking. Rocket science is full of stuff like that, and that's where the phrase "it's not rocket science" comes from. Everybody touts around the phrase, "Oh, space is hard. Space is really difficult." But nobody ever bothers to delve into why it's difficult, because some of the thinking is completely counterintuitive. It's completely ridiculous thinking. Like, you're going to launch it with a leak? What are you, nuts? Yeah, of course. Launching it with a leak that we understand is safer. That's actually better. That is safer for the crew than trying to take that whole thing apart and putting it back together. And that's really counterintuitive. You wouldn't think about it that way. Yeah, I'm good at this, and you get Spaceballs quotes. That's right. Yeah, so hopefully that clears some things up. So now that you guys kind of understand that, right? Listen to some of these questions, and you'll see why I'm like, ugh, you just made my brain hurt. But then again, once again, there are people that are trying to learn, and I understand that. But here, listen to the next question. There's only a couple more.
Yeah, good question. I would say...
Here, let's back it up.
To recap, hello, everyone. Thank you for taking our questions today. This one is for Steve. So just to recap, we're going to launch, even though there's a leak. So my question is, how confident are you that this issue that has caused the leak because of the seal in the thruster control system, are you confident that won't worsen during the launch vibration, plus being in orbit and then re-entry? I know you're talking about that, but it sounds like there's definitely some concern if you guys are thinking of backup plans. Thank you.
They wouldn't have set a launch date if they weren't confident in any of that being completely fine. Once again, crew flight test. Crew, operative word. They wouldn't have set a date on June 1st if they weren't sure. All right? See what I mean? See how weird that question sounds now that you understand the context? It's a very strange question to ask. Watch. I guarantee you they'll pause for a second and they'll be like, yeah, okay. Well, watch. They're good. Steve's going to say that right now. Ready?
Yeah, good question. I would
See?
say...
See? I told you!
The reason we're confident...
See?
Two different aspects of confidence in flying.
Yeah,
one, we've characterized the leak through various pressure cycles, and the leak is relatively stable. And then we've, as Mark said, done a couple of bounding analysis. We actually, as Mark said, took the whole seal, assuming the seal is not in this particular flange, and we can manage even that leak rate, which is 100 times worse than this one. And also, we've looked at the other manifolds, and they're not leaking. And then we have a really good analysis of the structure, and then what the stresses are in this particular seal. And I would say the ascent time frame is not going to put a lot of stress on this particular seal. What happens when the seal is pressurized, or you have pressure across it? I mean, it takes a certain set in the groove that it's in, and it expands against the walls, and it's in a stable configuration. When we've looked at analysis of what the stresses are in the particular seal, it's almost the worst case is when we cycle it. We cycle it open and then closed. That's where we think, when the leak rate increased, we think whatever the defect is in the seal, we were exacerbating that defect and making that grow a little bit, whether it be a little crack or a little imperfection in the side of the seal. With this kind of pressure, it doesn't take a very big defect to get these kind of leak rates. And so we think it's stable. That's why we think it'll be fine during ascent and the rest of the flight. And we also, on the other side of it, we looked at, well, what if it grows? Can we manage it? And that's what is giving us confidence to proceed into the flight.
They basically figured out what the leak rate would be if there was no O-ring in there, and even, which is like 100, Rocket Guy, you said it right. I'm going to paraphrase you here for a second. They did some testing on it to see what the leak rate would be with no seal in there, just metal on metal contact, which would cause an insane leak. You need O-rings in this stuff to seal up, right? That's 100 times worse than the leak that they're seeing. So we're talking like 1,000 PSI a minute leak. And even 1,000 PSI a minute leak in that line is acceptable. That's how much of a pain in the butt it would be to send this capsule back and take it apart. Now, I know that seems like, well, they're just going to, that seems backwards, but they understand the configuration, and the configuration of that thruster is stable. That was an important thing. That's why I keep pointing at the camera. I'm trying to listen to that part. Steve said it was stable, meaning they understand where and how it's leaking. In that particular case, because that behavior is well understood, taking it apart, putting it back together, now you don't know what that thing's going to do. It might leak again. What if it does? What if it's a defective seal? What if it's a defective pipe? What if that leak is somewhere else? The fact that they understand how and why and where it's leaking makes it safer, even though it's a leak and that's ideally not what you want. Weird, right? Holistic assessment, as Poison said, all things considered. Yep. Stop poking you. Poke you all I frickin' want to. Hey, Chief.
Thank you, Steve. Next up is Elizabeth Howell with Space.com.
Hi, everybody. Thanks for your time. This probably is for Dana. Can you explain how long we can hold that port open for Starliner if the delay persists beyond, say, early June? What sorts of factors you might have also in terms of spacewalking and other activities that might influence future launch dates? Thank you.
Sure. Let's see.
Hold on 1 second. What's up? Oh, yeah. Give me 1 second. Here, I'll be right back.
We're pretty flexible all through the summer. Currently, we're planning the spacewalks on targeting June 13th as the start of the first one. We'll keep them about a week apart. But we have flexibility, so there's no specific driver for exactly when we do them. We can do the spacewalks while Butch and Sunny are on board. We'll stay away from things like docking, undocking, and major handover days, but we've got flexibility in terms of where we put them. We've got Northrop Grumman flight planned for August. That's a berthing vehicle, so that's also not an impact to us. So other than actually deconflicting the specific berthing day,
or ran out of gas.
CFT docking day, which is just a really small cutout, that's not an issue. In fact, the extra helping hands on board could be helpful with that kind of a cargo mission. So really, the next activity that we have would be our next crew exchange.
Yeah, Tessa, exactly.
Out in the August time frame. That's the next time the docking's moved. And, of course, those are things we can adjust to if we needed. So we're pretty open and flexible on station and can move things around.
They're talking about timelines for capsules going, the manifest for going to and from the ISS. Yeah, it's called cutout windows and stuff. Yeah, that's no big deal.
Thanks, Dana. Next up, we have Andrea
Ricardo
from the Houston Chronicle.
For sure.
Hi. I'm still trying to find a very high-level way to describe this deorbit redundancy for our readers. Steve?
There's more than one thruster. That's it. You wanted a high-level one? There's multiple pressurant systems, isolated helium control systems for each valve, and that's going through a thruster block controller. The low-level way, there's multiple thrusters. More than one thruster that do the same thing. It's directional fault redundancy. Sure. I don't know what HSR is, Dax. I'm not sure what you're talking about. But the high level way is that they're able, so we know from their fault tree analysis that they talked about that they're able to isolate helium valves. Because they can isolate redundant helium valves, you just shut that thruster off. Just switch the valve off in the block controller, no problem. That's probably what they're going to do. Just saying. The hot staging ring. I've heard that the HSR, that this heat hot staging ring will lower the center of mass position it was supposed to where it was supposed to be in, and that's why they lost control with the grid fins. They weren't made for that center of mass positioning it had after getting additional tons thanks to the hot staging ring. I don't think it would throw the center of mass off too bad, dude. I would say that it's a control problem with the gimbal thrusters. There's no way that, even if that hot staging ring weighs like 2 to 3 tons, right? Let's say it weighs 5 tons. How much mass is 33 Raptors? I don't think it would throw the center of mass forward enough to throw off the moment control from the gimbal. I think that IFT3 landing was a avionics thing. A control parameters issue. The grid fins were gimbal locking. Yeah, there was a avionics loss of control that we saw one of the thrusters stick, or one of the grid fins stick. It stayed like that. That's loss of control. That could be induced from a differential center of mass. Could be. I would say that's more likely a controls systems parameter, conservative parameters, because you've never landed a super heavy before. I don't think the hot staging ring is enough to throw off the center of mass that induced control of the grid fins will be. Control of the grid fins would induce a loss, a loss of control. They would gimbal lock. I don't think I think that's much more a flight parameter system. Like that's the brains, that's the computers, not so much the mechanical design of the booster. But I could be wrong. That's just me speaking from my gut. Dax, one thing I try to do is dude, I know plenty of people that work at SpaceX. I know plenty of people. I could probably get the information if I really wanted to, but I don't. I like using my analysis and judgment to analyze the situation. I like using my analysis to analyze. Oh, great choice of words there, Skip. No, I like using. I use this as a logic exercise for me to understand where SpaceX's mentality is at. That's why, me saying that I don't think it's going to throw off the moment stems from an understanding of physics and analysis, like what I'm teaching you guys here with this teleconference, right? I could be wrong. I don't think it's enough to throw off the center of mass that the moment of control, the control moment that's induced from the grid fins moving is enough to lock them and just not be effective. I really don't think so. If I call it correctly, Raptor 2 is 1.4 tons from what's public. Okay, 33 times 1.4. That's way bigger than a 5-ton staging ring, and I doubt that staging ring weighs 5 tons. Not even. I really don't think so. I know you're just saying that's what you heard. Yeah. That's fair. That's fair. Anyway, back to this.
Is this the gist? So you have a variety of thruster combinations that can be used to ignite the engines and leave Earth's orbit to come home. You identified a very unlikely scenario where certain thrusters could go out and you didn't have a way to come home safely, but you've since found a solution. Is that like a fair way to say what's going on here? Thank you.
Yeah, I think that's exactly the way we would say it. We have a lot of redundancy to come home. And like we said, we have a 4 OMAC option, which and redundancy on those thrusters. If you just look at the number of thrusters we could use, there's redundancy there in each of the doghouses. A 2 OMAC option, and it's really only a very narrow case that you could get into where the normal backup, the third backup option, which is the second backup option is the RCS thrusters, which we normally use 8 of those. Now, instead of having to use 8, we would use 4. Did I answer your question, hopefully?
Yeah, thanks, Andrea. And thanks, Steve. Next up in the queue is...
Can I hear that question again? Sorry,
Is that like a fair way to say what's going on here?
Very technical station and can move things around, helping hands on board.
Hi, I'm still trying to find a very high-level way to describe this deorbit redundancy for our readers. Steve, is this the gist? So you have a variety of thruster combinations that can be used to ignite the engines and leave Earth's orbit to come home. You identified a very unlikely scenario where certain thrusters could go out and you didn't have a way to come home safely, but you've since found a solution. Is that like a fair way to say what's going on here? Thank you. Steve, is this the gist? So you have a variety of thruster combinations that can be used to ignite the engines and leave Earth's orbit to come home. You identified a very unlikely scenario where certain thrusters could go out and you didn't have a way to come home safely, but you've since found a solution. Is that like a fair way to say what's going on here? Thank you.
Yeah, I think that's exactly the way we would say it. We have a lot of redundancy to come home, and like we said, we have a 4 OMAC option,
the hot staging ring,
which and redundancy on those thrusters. If you just look at the number of thrusters we could use, there's redundancy there in each of the doghouses. A 2 OMAC option, and it's really only a very narrow case that you could get into where the normal backup, the third backup option, which is or the second backup option is the RCS thrusters, which we normally use 8 of those. Now, instead of having to use 8, we would use 4. Did I answer your question, hopefully?
Yeah. I mean, she described it, I guess, in a fair way. The low-level answer is that there's other thrusters. The high-level answer is that they have the ability to isolate thruster control actuation with those helium valve control, with the helium. Here, I can show you a picture. The picture is probably better. Where is it? Did I X out of it? Here, let me Control-Shift-D. Yeah, there we go. This is the one. Like I said, I'm not a rocket scientist, but if I'm looking at this and understanding it correctly, that looks like an actuation block right there. So how many thrusters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 1, 2, 3, 4, 5, 6. Oh, there's 10. There's another one right there. So we got 6 lines going out right there, and clearly this is a block with a bunch of, there's electronic solenoids actuating the pneumatic solenoids here, from what I can tell. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you could have an input that seems to be going out the other side too. 2 more on the side too. These right here might not be helium actuation; those could be fuel lines. But it's hard to tell. But yeah, there is other ones on the sides right there. Long story short, that looks like your valve actuation control block. Once again, huge guess, because yeah, actually, yeah, there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. 6 sides here, 6 sides there. Boom. That's most likely the actuation control block. What else would it be? Right? There you go. See, there's 6 on this side, 6 on that side. Yep. 2 on the side, roll control. It's 12. They can isolate the system. That's what I'm trying to tell you. And that's good redundancy. That's good design, guys. Sorry, it's good design. People can hate on Starliner all they want. That's smart. That's a smart way to do that, especially if you're opting for a pneumatic control system. My question here in this regard would be, why are you using pneumatically controlled valves instead of electronically controlled valves? Electronically controlled valves would save you a ton of mass in this design. But see, I'll answer my own question. All right, I'll answer my own question just by doing a little logic exercise. So why are they doing it that way? What are they trying to do? They're trying to use thrusters. All right, we know that. Why would helium actuation be a constraint here? Let's think about the context of these thrusters. Did Boeing design these thrusters? Nope. Rockwell did. They're shuttle thrusters. They're probably carrying over a legacy system that's been upgraded, which is why, because if you cast your mind back to the 70s, you know, when the shuttle was designed, when these thrusters were designed, right? Full electronic control and electronic actuation of thrusters was not a thing. It'd be a lot safer to use a pneumatic system, a mechanical system, instead of an electronic one. My guess, to answer my own question, is that because propulsion research is expensive and these are reusing They're not the actual shuttle thrusters. They're new ones, but it's the same design. They're reusing legacy designs here to save on research and development, which is fair. That's a fair thing to do. And because of this, you're using a pneumatic actuated system instead of an electronic one. Now, SpaceX on the Draco thrusters, those are electronically actuated solenoids. They look like fuel injectors. SpaceX, there's plenty of pictures around a Draco engine. It's very simple design. But SpaceX did all their propulsion research themselves. People can hate on Starliner. That's smart as how I'm going to hear that quote. Yeah, whatever. Yeah. If you want to paraphrase me, you're gonna do me like that. You're gonna do a press on me, Scary. Yeah. No, that's not a bad way to do it if your design constraint is reusing thrusters, because designing a thruster block is not nearly as complicated. Designing a controller block like this is not nearly as complicated as redesigning the entire freaking thruster. Fun fact. I wonder how much time they saved in qualifying them for flight, since some percentage of thruster design was already qualified and known and probably just used as is, like the valves, for instance. It probably saved a lot of time, Rocket Guy. And a lot less voltage and current, for sure, James. Yeah. I mean, you have helium, which is very low mass. The electronic system actually might end up being more mass, despite being a lot simpler, right? You're going to need a lot more relays, right? Unless you design your architecture around a voltage, which I'm pretty sure that's what SpaceX did, because they clean slated the entire Dragon design. It's not really based off of anything. It's based off of research programs that are being done in the past. Like NASA did a research program for the heat shield that would ultimately become Dragons. SpaceX borrowed a bunch of like half-completed research projects and used that to put together a capsule in 2008, 2009, and 2010. And they've been iterating off that clean-ish sheet design since. Use what you know. That's what I mean. Sometimes it's better to use a system from the 70s because you know it, you understand it. Because it's hard to develop new systems and understand them. Look at SpaceX with the Dragon capsule. Look at the DM-1 capsule. It popped on the test stand. Because of inexperience, because SpaceX had never done that before. Then nobody's ever used an integrated hypergolic propulsion system in their capsule for launch escapes. No one's ever done that. Right? So you're going to run into teething problems. Every spacecraft does. Every single one of them. That's the one thing that you can be absolutely sure about. That's something that you don't understand is going to happen like this. And that's what they said at the beginning. They said that at the beginning of this press conference. Anyway, let's finish this up. When did that capsule explode? I think it was 2019, but I'm not sure. Yeah, Tessa, there you go.
Thanks, Andrea. And thanks, Steve. Next up in the queue is
for sure, Rocket.
Ahmed from the AFP.
Hi, thanks for taking my question. Just a couple parts.
Yeah, there you go, Ricardo. For sure.
My understanding is correct. You'll monitor the leak in the pre-launch period, and then Starliner will fly, dock with station, and you'll check on the leak again then. And the second thing was just for context, how common or uncommon is it to fly a crewed spaceship when a leak is identified as being
nice,
present?
Oki. There you go.
Thank you.
Yeah, again, we'll once we activate the propulsion system, we'll be able to take a look at. We'll use the repress cycles in the helium system to take a look at the size of the leak, and we can do that once we pressurize out at the launch pad for flight. That happens about 4.5 hours prior to launch, and then we'll watch it. It takes about an hour for things to stabilize in the system, and then we can take a look there. We'll get another look at it, as you said, after we dock, and then we can see what the pressure decay rates are and compare that to what we did back in the VIF. And then, we have flown vehicles with small helium leaks. We've flown the space shuttle with a few regulators in that OMS and RCS system that were leaking, and we've had a couple of cases with Dragon where we've had a few small leaks as well. So.
Oh, wait. What was that last part? Wait. Steve, rewind. Hold on. What was that last part? Wait.
That ohms and RCS system that were leaking, and we've had a couple of cases with Dragon where we've had a few small leaks as well. So.
Interesting. That really gets the noggin jogging. It happens all the time, guys. It's a low-level risk. Happens to everything. It's a pain. The helium's a pain in the butt to move around, guys. It's so tiny. So small. So small. Example of a licensable NASA tech. See what I mean? Stuff happens. It's just, you know what? Like, this is going to sound ridiculous, but I appreciate Boeing being super transparent about this. I mean, I think NASA's kind of holding their feet to the fire, but hey, whatever. This is cool. Them being transparent about this is a great opportunity for us to understand. This is the best stuff. From them being super transparent about this to learn about fault tree analysis, risk aversion, risk assessment. This is all super important stuff if you want to work in the spaceflight industry. This is super important stuff to learn, and it takes a long time, but these are the best lessons for it. The best lessons for it. Nothing even comes close. That didn't take long. What is this? How deaf can you be? Come on, man. Yeah, Ricardo, Flight 4 date looks to be okay. Like, see here, the way and forgive me for presuming. I can't. It's hard to figure out tone from text here, but if you're keeping score at home, so implying the implication there is that you're comparing it to Dragon. Okay. The problems that Boeing has found with Starliner spacecraft on the ground since OFT2. Prop system valve, slammable tape, parachutes, helium leak, prop system design vulnerability. Crew flight test now set for June 1st. The implication here is that Starliner has all these problems, and they're probably going to encounter more problems on orbit. Right? That's the implication from that statement. If you guys think I'm presuming too much, you let me know. The implication is that Starliner bad, Dragon good, right? That's the problem. But yet, we just heard Steve Stitch in the press conference say that every spacecraft has had this problem, Dragon included. See what I mean? Like, I'm not trying to dump on Eric. He's fine. Like, I get it. And I'm not going to sit here and pretend like Dragon and SpaceX ain't eating Boeing's lunch when it comes to launching people into space. Oh, they absolutely are. Oh yeah, Boeing promised us crewed spaceflight to the space station like 2017 or 2018. Yeah, you're about 6 years late. Better late than never, I guess. I get it. I understand. But also, to imply that finding problems on the ground is a bad thing is kind of ridiculous. Dude, what? Oh, these are the problems they had on the ground. What other problems are they going to have in space? Like, would you rather them find these problems in space? I don't understand. Yeah, remember capturing the flag? Yeah, exactly. The Boeing guy said we're going to get that flag. Oops. Yeah, that statement held up real good. Are you going to read the Flight 3 update later? Sure, Nidodo. Yeah, we can do that. There's a weird thing going on here. Like, people want to make it seem like, oh, it's SpaceX versus Boeing. I really don't think we can afford, as spaceflight fans, to take sides at this point in time. I don't think that's smart. This ain't Ford versus Chevy, okay? The spaceflight industry, especially the commercial industry, is a very fragile ecosystem right now. It's not... Dude, if you look at history, the commercial market for spaceflight has collapsed several times because it's a rather volatile and unstable industry just due to the nature of what they're doing. Collapsed in the early 60s. True story. Collapsed in the 90s with the dot-com bubble. This happens. I don't think, look, I don't think that the spaceflight economic ecosystem is robust enough to take sides. I think that's really stupid. That is a really stupid thing to do right now. Taking sides right now is basically taking sides, saying SpaceX is better. And I'm not going to sit here and pretend like I ain't a SpaceX fanboy like everybody else. If anything, I want Boeing to be more like SpaceX. They should. Come on, guys. You said you were going to launch 6 years ago. What are you doing? What's going on? Like, I'm not going to sit here and just bury my head in the sand, right? But also at the same time, people that seem to imply that it's SpaceX versus Boeing, or seem to imply some tribalism when it comes to spaceflight here, that's really stupid. That's a really stupid thing to do right now. You're arguing for a monopoly. You're arguing for SpaceX to just do everything. And that's fair. Like, dude, I get it. Their results speak for themselves. I understand. But I honestly think that's a very bad idea. You're arguing for a monopoly in the commercial industry. That, you understand, that is not growth. That is degrowth. That is consolidation of a burgeoning commercial industry. You're pruning the hedge before it's fully grown. That's really stupid. That's a really stupid thing to do. That's not smart at all. You're choking off the industry by taking sides right now. That's really stupid. I really don't think that's a good idea. That's purely my opinion. You can disagree with it. Totally cool. Notice how he didn't do a score for Dragon. Yeah, I don't get it. Like, I don't get what the point of that statement is, other than to drive some kind of some type of ideological thing that SpaceX is better than everybody else. And you know what, man? Like, here's the thing. He's not wrong. I don't think it's wrong. SpaceX is doing things that with Dragon that they're dreaming about, like, Dragon is going to fly on Polaris Dawn, mimicking, with Isaacman, with Jared Isaacman, which is awesome. I'm super psyched for that mission. It's going to be amazing, right? That's going to be super freaking cool. Boeing would, they wish they were doing that with Starliner right now. They're just trying to get to the ISS right now. And that's, but once again, I see people make this mistake all the time. You're going to say, oh, defund them. Oh, defund them. Oh, defund them. Just have SpaceX do everything. Just have SpaceX do everything. Just have SpaceX do everything. Okay, so one, that's never happening. I will tell you that right now. The Department of Defense, NASA, any government agency will never, ever rely on one systems architecture to get into orbit. They tried that once in the 80s. It didn't work. Bad idea. Never going to happen. Ever. Until the ecosystem is healthy enough to take sides. A strong, robust economic system. Like, basically to the point where the capsules are here to stay, and the Starliner and Dragon are here to stay, and there's no possibility of the market contracting. Okay? Only then is when I think it's wise to take sides and be like, oh yeah, brand loyalty, etc., right? That's fair. How about Dream Chasers? Sierra Space has even more opportunity to compete with Starliner. Yeah, exactly. That's what I mean. And taking sides right now, Crafty, is going to squander that opportunity for the market to grow. You're arguing for degrowth here by taking sides. That's the dumbest thing I've ever heard. It's like, why would you do that? I don't think people realize how fragile all this stuff is. Look, man. I've said this once, I'll say it again. I've said this many times on stream, all right? Like, all joking aside, I know we have a good time here. Look, man, I was a spaceflight fan in the late 2000s, going into the early 20 teens. You get what I'm trying to say. Like 2008 to 2010. All right? I've been a spaceflight fan for a very long time. And I get it. There's some people here that are spaceflight that are here around for the Apollo program. And man, I am forever jealous if you got to see a Saturn V launch, okay? Now, with that being said, I was a fan I've been a spaceflight fan for like 20 years at least, right? And don't get me wrong, it's not about tenure. What I'm trying to explain is that I saw Columbia explode. Saw that. I was there. Not there, like I watched it on the news, right? But you see it. Seen what it's like to have crew failures affect NASA's goals, right? I've also seen what it's like to have the rug pulled out of the entire spaceflight industry, because that's what happened after the Great Recession. They tried to pull the plug on NASA completely. That's the reason why we have SLS, because the congressman said, frick you, that's not happening. Why you're trying to pull the plug on all of our jobs? What are you, nuts? Are you absolutely crazy, surrendering our aerospace capability and relying on a commercial market that doesn't exist? Operative word. Neil Armstrong and Gene Cernan gave talks. They testified to Congress about the volatility of the industry and how it's dangerous to rely on a commercial company that hadn't launched anything into space at the time. This was back in 2008, 2009. They had launched one small sat payload into space, a tech demonstrator for the Air Force. Why that's a very bad idea? Because the commercial industry is very volatile. Neil Armstrong and Gene Cernan had lived through the dot-com bubble collapsing and destroying the commercial launch industry in the 90s. And even before that, consolidation of NASA, right? When NASA was first formed, 58, 59, 60, 61 into 62. When NASA was formed, it killed the commercial satellite launch industry. Not a lot of people know this. It killed it. Look up when the first commercial communication satellite, Telstar 1. Look at when that launched into orbit. It's weird how we didn't see much after that until the 80s. Funny. Curious. Yes, provocative. Read about it. It's important. The commercial industry is still super volatile. And I remember a time where we almost had nothing. Nothing. Don't take sides right now. That's stupid. That is really stupid. Anybody that's taking side, all SpaceX, Boeing's a bunch of clowns, SLS sucks, blah, blah. Anybody that's doing that kind of crap, you're arguing for degrowth. You're arguing for consolidation of the industry. And I think there's legitimate arguments with SLS. Please launch more. For the love of Christ, that thing is expensive. Launch more. What the hell are you guys doing? SLS was supposed to send people, Artemis 1 was supposed to be in 2017. You missed the mark by 5 years. What the actual frick are you guys doing over there? Can anybody here predict a realistic budget timeline? Anyone? Anyone? Like, it's not above criticism. But arguing for those programs to go away is arguing inadvertently for consolidation of the spaceflight industry. Getting rid of SLS is not just getting rid of a rocket. It's getting rid of a ton of commercial providers that provide parts for it. Maybe some of those commercial providers fold because SLS goes under. And maybe some of those commercial providers also provide valves, electronics, controllers to SpaceX and Boeing. That would be a catastrophic implosion, even though it's a government rocket. It would be a catastrophic ripple effect through the commercial market. That's really stupid. That would be a really stupid thing to do. SLS is carrying a heavy price tag, no doubt. And that's not above criticism. Absolutely not. Seriously, $1 billion for one launch. If you launch it more, probably would go down. But are you kidding me? Kidding me, guys? This is the best you can come up with? Come on. However, getting rid of that will cause a catastrophic ripple effect through the commercial market. That's not good. That wouldn't be good. That wouldn't be good. Getting rid of SLS gives the HLS program no purpose. That's less money for SpaceX. Do we really want that? And for the idealistic people out there that say, oh, well, they should just pull funding from SLS and give it to SpaceX. Oh, yeah, because that happens all the time in government programs, right? Fiscal responsibility happens all the time. Oh, no, yeah. I tip my cap to your idealism. Paul's with the prime sub. Thank you very much. See, that's what I mean. That is the stupidest thing you could do right now. This is stupid. It's so stupid. Oh my God, how can you be so tone deaf? I don't get it. Yeah, all that institutional knowledge from the shuttle program got flushed down the toilet. But do you guys know the day after STS-135 landed, 5,000 people on the Space Coast lost their job. That's 5,000 less jobs for the space program. And because they canceled Constellation and pulled the rug out from NASA, you lost even more institutional knowledge. We wonder why it's taken so long.
Discovery.
Ridiculous. You lost all the people that put the stupid thing together. And then you tried to build a vehicle based off of the vehicle that all those people had jobs for putting together and then had trouble putting it together. Weird how that works. shocked Pikachu face, bro. Oh, it drives me up the freaking wall, dude. I get so pissed at this stuff, dude. I get so mad. Oh, what are you doing? Stop it. Stop that. What are you doing? What's up, Noswolf? I'm doing all right, dude. I'm good. I think I just got to take some blood pressure medication. Breathe. Where's the bag? You know? I am disappointed. And if it's one thing I do not like to be, that is to be disappointed. Someone clip that. It was a bag, blood fam. Get your mind out of the gutter, you dirty. Anyway. Stop ranting. You have the flame trench to do it again soon. Oh, I'm gonna, Hellzekin. Don't get me wrong. This is just a dress rehearsal. I'm gonna go the frick off. If they let me. I'm gonna go off. Right, a bag. Anyway, thanks for coming to my TED Talk. That was the Starliner press conference. I don't feel like listening to the rest of it. I really don't feel like listening to the rest of that. Want to play Fallout? Don't forget, we have the Flame Trench in about 3 hours. Dude, for the love of all things holy, please go out. Oh, I will. We also have Friday Night Racing tonight. I can't do Friday Night Racing tonight, Nova. My in-laws are here. I already feel bad that they're just sitting in the house doing nothing and I'm working. That's not cool. You'll understand. You know, if you want that, if you do want that, when you get to that point, you don't do that stuff. So all the more reason to do Friday Night Racing. I actually like hanging out with my in-laws, to be honest with you. Primo's family is all from Detroit, so just it's kind of law that they like automobiles. I too like automobiles, so yeah, I would hope I'm on their good graces. I might not be, but maybe. Do you still dream of Chernobyl? I want to know. Yes. Jens, I want to go back to Workers and Resources eventually, dude. I too, Pocket guy. Mower update. I heard the mower drive into my mower storage, which is through that wall right there, so I would assume my lawn is... I would assume my lawn's all nice and cut good, boy. Want to discuss Shadow Zone's reporting? Sorry to bring it up if it's been discussed. I haven't watched it yet. Yeah. Oh, jocular mowing antics. Yes. Tell the in-laws I said, hey, will do. If you guys wanted to talk about Shadow Zone's video, I haven't watched it yet. I only saw the thumbnail for it on Twitter, Twixer, Xer, Mixer. You guys remember Mixer? All right. Yeah, I know. That was the punchline. That was a joke. Are you laughing? Yeah, all right. How would I submit a question to the Flame Trench? What's your question, John? I mean, you could. There's a way to do it. You have to tag at NASA Spaceflight, I think. And yes, I did actually laugh. TLDR, Shadow Zone revealed that Take-Two did the exact same crap that NASA did with Axon Constellation, but with KSP2. I'd have to watch the video, Nova. I'd have to go and watch it. I haven't asked Shadow Zone if I could react to his video. I'd have to go shoot him a DM. I need more context to that statement. Yeah, where is he getting his info from? Because guys, I'll be honest with you. I'm just trying to sit back and figure out what the heck's going on, dude. I haven't weighed in on this at all, and I don't want to right now. I don't think it's wise to do that. He's got a lot of sources, okay? Nice. Wondering how many flights the folks think Starship needs to hit before it won't require a special license like a commercial airliner. Okay, Stuart, railroader. Yep. Someone who worked on KSP2. Okay. Yeah. I know those same people, Erudite, and until I hear what Shadow has to say, I can't say whether I agree or disagree, you know? I know a lot of the KSP developers. Yeah, I have very good relationships with a lot of them. But anyway, so John, your question. How many flights does Starship need to hit before it won't require a special license? That's a really good question. So, guys, the reason why the FAA has been kind of okay, so, all right, John, let's discuss some points here real quick. I'll change up the title here to the Space and Rocket Review. Let me change it up. I got to change it up on both streams. Okay, so here's the thing. It seems like the FAA is holding up SpaceX something fierce, doesn't it? It very much does. And to an extent, I'm not going to say that that's not what's going on. But once again, we got to understand, it's important to understand why, okay? So why is the FAA, mishap report, another freaking mishap report? You're screwing with SpaceX's rapid iterative testing. This is ridiculous. Why are you doing it? What the hell, guys? Like, come on. They launched all those test flights like this one right here in rapid succession. They didn't need a mishap report every freaking time. Right? So why all these problems now? Well, okay. 2018, 2019, 2020. As part of Space Policy Directive 3, which was an executive order that was signed by the president at the time. It's not a bad piece of legislation, okay? That basically made the FAA your one-stop shop for certifying A, a commercial launch site, and B, a commercial launch vehicle. Okay? Why? Why would you do this? Because before, you had to go to NASA, you had to go to the NOAA, you had to go to the FCC for communications. Rockets have antennas. You had to go to the FAA in some way, shape, or form. All right? You had to go to the Department of Fish and Wildlife, the Environmental Protection Agency, and state and county officials wherever you're trying to build your spaceport. The government actually doing something useful for a change recognized that if they want to bolster the commercial market, they need to start treating rockets, because the high frequency of launches is going to happen because the commercial market is expanding, right? Just like what we were talking about a second ago, right? The commercial market is expanding like crazy. Well, with every expansion comes a contraction. Okay, that happens. It's going to happen eventually. You know, there's going to be ups and downs in any economic system. That it has but how much elasticity it has, it depends. I don't personally, like what we were saying before, I don't think there's enough elasticity in the commercial space flight economy to pick sides. That's stupid. We won't rebound from a contraction. Historically, that's accurate. Every time. That's why ULA exists, because the commercial market imploded in the early 2000s, but that's another story. Now, so the government realized that they wanted to leverage the commercial industry and expand this new economic sector. So they made it so instead of having to go to all those different three-letter agencies, you go to the FAA, and the FAA is what communicates with those agencies. They're the intermediary, because they wanted to start treating, that's the way that airports and airplanes are certified. They wanted to start treating spacecraft like airplanes. Spacecraft launching is not going to be something that requires a notice to air missions. It's just going to, they want rocket launches to jive with the commercial airline industry. Just treat it like another vehicle flying. It's just another aircraft flying up into space. Unrestricted launch corridor, unrestricted climb, right? You know, so imposing a notice to airmen, right? Notice to marine traffic, all this other stuff that you have to do to get a launch on the books. Well, if you're launching every week, that's a very inefficient system. Okay? That system, that regulatory framework is really only designed for maybe one launch a month at the very best. There's a need to consolidate it because the industry is expanding, right? Not deregulate, consolidate and make one-stop shop to optimize flow. You're not deregulating anything. Okay, now, so SpaceX has to go to the FAA. That kind of started 2019, 2020, right around when they landed SN15, give or take. Now, with that being said, actually started a little bit before that with the launch licensing, et cetera, et cetera. Now, with that being said, the reason why we get a lot of downtime between these flights and why we get mishap investigations is because the FAA is not just looking to certify Starship. They're not just looking to do that, okay? They're not just looking to certify Starship. And anybody that seems to imply that the FAA is holding up SpaceX for some kind of ulterior motive is stupid. That's dumb. What they're doing, okay, is, well, what does the FAA know about making new launch sites? What does anyone know about making new launch sites? When's the last time we built a new launch pad before something like Boca Chica came along? Up until now, the framework has been to just reuse a pad that we built during the Cold War to launch ICBMs. Slick 40, or government satellites to payload. Slick 40, Slick 41, 39A. You get the idea. There's no framework for developing a commercial space flight launch facility, basically a commercial spaceport. There's no regulatory framework for that. Does there need to be regulatory framework? Well, anything that flies in the air should probably have something so we don't have a rocket crashing into an airplane. Rockets hitting airplanes are not rockets. Those are called missiles. Yep, don't want that, right? So the reason why this is taking so long is because as the FAA is qualifying Starship for flight, the FAA is learning on how to do it. What do they know about spaceships? But spaceships are close to airplanes, so it's a logical jump. Here's the most important part, the spaceport. The FAA is moving to certify commercial spaceports like anyone could certify a commercial airport. That is huge. That could allow anyone to build a launch site pretty much anywhere as long as you get FAA approval. We could see spaceports pop up like airports, popping up like weeds. But since this is the first time they're going through it, the FAA needs time to learn. And I would argue that Starship is the best vehicle to learn this with, right? Because you have to take into account full reuse, right? You have to take into account turnaround time. You have to take into account the environmental impact of launching as much as a jetliner, something the FAA knows a ton about, right? That's really smart. It's a really good way of doing things. I don't necessarily mind that it's taking a long time between mishap reports. I think that's really smart. See, that's why it's taking so long between flights, because the FAA is figuring out what it takes to make a commercial launch site, make the regulatory framework for certifying a commercial launch site work like registering a commercial airport, small airport, fixed base operations, stuff like that. They're figuring out how that all fits together. And I would argue that Starship is the best vehicle to do it with. Now, the downside of that is that SpaceX does get held up a little bit. I'm pretty sure if there was no FAA mishap report, Flight 4 would already be in the ocean. And that does suck. But you got to understand, this doesn't just work for SpaceX, right? I mean, this doesn't just work for Boca Chica. If SpaceX wants to build more Starship pads in the future, well, now we know how to do that. Now we know what's needed to build a Starship pad. Now we know what's needed to make a commercial spaceport. Maybe SpaceX wants to do oil rigs in the future. They've talked about that before. That'd be really easy to get FAA approval for that because they already know. They already tested it at Boca Chica. Anybody else, maybe you're a Rocket Lab or something, or, Relativity, and you want to do a commercial spaceport, somewhere that's not a pre-existing space launch area, right? So you want to do that, right? The regulatory framework and precedent there, and say you're even launching an expendable vehicle. It should be easy to get this all certified in the future, probably about as hard as registering an airport on FAA maps. It's smart when you think about it. It is hedging your bets for long-term commercial spaceflight economic viability. I think that's really smart. That's a really good way of doing things. Really, really, really well thought out. It's very rare that you get such lucidity from the government, and such like a decision like that has very, very long-term effectiveness, right? That's really smart. That's a really good way of doing things. Do you guys want to be able to get on a rocket and go take a vacation in low Earth orbit for a week in the future? This is the start of being able to do that. This is exactly what happened with the commercial airline industry after World War II. Same stuff. Actually, it was easier because all the airports that they made for all the planes that we made for World War II. So it's really easy to just hop into a commercial airline industry from a commercial government bomber provider, right? Doing this now will be able to leverage in the future people building spaceports in your backyard. Not in your backyard, but obviously environmental impact, I get it. Like not in your backyard, but dude, we can see spaceports in every city, just like an airport's in every city. Wouldn't that be something? Maybe point-to-point hops. You never know. This opens up the door for that. So us waiting a couple extra months between Starship flights doesn't really bother me in the grand scheme of things, because that means in the future we might be able to get these daily Starship flights that Elon is talking about. And I think that they're working together. To be 100% honest with you, I think they're working together. I think the FAA and SpaceX are in cahoots. I don't think the FAA is intentionally hampering SpaceX. I think SpaceX is helping the FAA write the book on what it takes to make a commercial spaceport. And I think having SpaceX do that, I would prefer that out of any other company. Can you imagine if both, you know what I was going to say. Can you imagine if there was another commercial launch provider doing this? There's no way this would get done nearly as fast. Think about it. Right? B-29 got turned into an airliner. There you go, Hellfish. Starship, we know, has feasibility studies with the United States Transportation Command. Starship is a cargo hauler, right? At least the government is looking at Starship for cargo hauling applications. Guess what? The resupply vehicles to support the war effort in World War II also made sure that Germany didn't get taken over by communist filth. The Berlin airlift. Where do you think we got all those freaking planes from? And they were serving a civilian resupply purpose. And that paved the way to the airline industry. Read about the Berlin airlift, guys. Everyone in Germany knows that one. Very important. Germany would not be Germany today if it wasn't for the Berlin airlift in the late 40s. That was very important. The United States supplied an entire city, a multi-million population city, West Berlin. They supplied it via airplanes only. And it's because we had all those airplanes from government contracts. Because they were resupplying the war effort. So they went from moving guns to moving food. Smart. Easy pivot. Biggest logistical flex of all time, for real. We sustained an entire city, a multi-million person city with airplanes for 18 months. It's ridiculous when you think about it, but we did it. See what I mean? Just because Starship could be used to move tanks and airplanes around doesn't mean that it couldn't be used to shuttle you guys up into a low Earth orbit tourism flight in the future. Because it absolutely would. I really think it would. And I think, John, that's why it took me a long time to, that's why I had to explain all this out. That's why it was a good question. Because, yeah, it's taken a long time. A couple months between flights is nothing in the scheme of things for you and I to be able to take a vacation to the moon in like 20 years. That's sweet. Greetings from Germany. That's how you know. I'm sure they taught you guys all about that, and if they didn't, I don't know what the hell your school system's doing. That's right, Evertech showed the Soviets we ain't screwing around. We're not going to allow, we're not going to allow communist filth to take over more pristine Western Europe. The frick out, man. Hell yeah, am I right? Hell yeah. Back-to-back champions, that's right, bro. Thanks. That was way more than I expected. Sometimes these answers take longer, dude. What are you going to do? Sometimes these answers take longer. What are you going to do? All right. As I'm getting kind of hoarse, I'm going to go refill my water bottle. Somebody linked me up. Unfortunately, Poland was not so lucky. I mean, Rafal, to put it very bluntly, and if you're watching with your children, just cover their ears for a second. Stalin was an asshole. Couldn't bargain with that piece of shit. And we lost an allied power because of it, and that pisses me off. But it's an asshole. What are you gonna do? All right. We're good. I'm gonna go fill up my water bottle. Link me up with the IFT3 mishap report. I want to see it. Alrighty then. Yeah, I want to know why our government is a freaking retirement home. Wait, Andrew, what are you talking about? We're talking about spaceflight, dude. I don't know. Get what you vote for? I don't know. Vote different next time. All right. Not space, but Edison has finished the conventional seating concept for the diesel electric truck. It looks very nice. Let me see. Oh, baby. I like that, Thomas. I like that a lot. Side-by-side timelines for 3 and 4. Cool. Blood Family, I ain't touching that one, man. Oh, that's killer. I love it. I love it. Could you get vodka? No, it's just water, Pigeon. Yep. Oh, simple. Oh, that's... Dude. I love it. It's just a truck. Simple. Doesn't need to be complicated. And it looks fantastic. That's perfect, man. Truck should be utilitarian like that. That's awesome. I really, really like it. Oh, yeah, Blood Rim, yeah. They will also offer it as a version with no e-axles to people to people who can drop in their own engines and make it a normal truck. How can one company be so incredibly based? Oh my God. Whew. Sorry. That is money. I love it. Make a long haul version. How many dollars is that? I don't know. I don't know. Thomas, do we know the price tag? Every truck will come with a parts list so people can repair their own truck. Oh, stop. Stop. Stop it. Stop it. That truck is very hench and very jocular, Riglet. It is the most jocular of jocularity trucks. It's highest on the jocularity scale. It is hencherific. Hands, I don't need them, fellas. It's joculistic. Oh, that is sick, dude. So, okay, just on a quick side note, what that truck is, that's an Edison. So, an Edison is an electric truck, but it's not just electric. It's a diesel electric. So you have a diesel power plant, and then instead of the transmission being right there, like right behind it, you have a generator. The diesel's attached to a generator. The generator generates electrical power, charges batteries, and then electric motors drive the wheels like a locomotive. I don't know why someone hadn't done this in the past. Like someone hadn't lifted the systems off of a diesel locomotive and put this on a truck. But diesel electric hybrid, like I'm generally not really, I don't really like hybrids. In the past, like I think it's better to go all EV or just stick with internal combustion. But honestly, this one I don't mind. For a long haul truck, hybrids make sense. Just like a hybrid, we've been doing a hybrid system in trains for 50 years. I don't know what, for long haul heavy trucks, I don't know why you wouldn't have done the same. Are their insides stolen from a Tesla? No. It's how they used to build submarines. Yes, even before trains, Bloodfam, that's right. Submarines were diesel electric, like Wuntas U-boats. U-boats. Palau class, Gato class, it's all diesel electric. They're hybrids. I'm curious to what the efficiency is over a plain diesel truck. Geek, it's like tenfold. The Porsche Tiger. Oh yeah, that thing that didn't pass acceptance testing. I remember that. The efficiency is tenfold. You know why? You can scavenge energy. It uses regenerative braking, just like a diesel would, just like a diesel electric train. You have regenerative element. The regenerative brakes charge the battery here. You can use the kinetic energy of a truck going down the hill to recharge your battery. I don't know why anyone hasn't implemented a scavenging system here. Now, a scavenging system like that doesn't really make sense for a car. Like, even though Teslas do it, right? Teslas do that to increase range. That's fine. That's fair. But for the truck, it really makes sense. Use gravity pushing this truck down the hill to generate power. The truck is your battery. The truck is a kinetic battery in this regard. Like, you have a truck at the top of a hill, right? A truck rolls down the hill. Instead of using the engine and the brakes will just take your kinetic energy and convert it to heat. And that heat just goes off into the atmosphere, right? This thing has the electric motors engaged going down the hill, and it generates power. The alternating fields inside of this electric motor, when it's rolling down, is going to generate power and charge the battery. Charging the battery is going to basically put resistance on the generator, and that's going to slow your truck down, but it also generates power. You're taking the kinetic energy of that truck and you're scavenging it and turning it into electrical energy. No other truck does that. Teslas do it. That's why Tesla brake pads never fade, because the electric motors are doing that to recharge the battery. This thing can do that, but you also have a diesel engine to be able to pull you up the damn hill, right? But you could scavenge that power right back. It's way more efficient, dude. Way more efficient. It kind of makes sense for a Tesla. Teslas do it once again. If you're doing all EV, it's done to increase range. But for a truck, it really makes sense, dude, because you paid in the fuel to get that stupid 53-foot trailer that's full of stuff, 50,000 pounds. You paid for that to get at the top of the hill. You can get almost all of that energy back. The only energy that you're pretty much going to lose in this particular scenario gets lost due to the resistance in the wires. It's very smart. I'm telling you, man, this truck is super well thought out. And the guy that started Edison is a long haul logging trucker in British Columbia in Canada. The guy is like, what the hell am I going to do with an electric vehicle out in the middle of the forest? What if we run out of batteries? You're screwed. His whole impetus for designing this was the rationale that Tesla Semi makes a great day truck if you're driving around the city. But long-haul truckers can't use that thing. What the hell are you going to do with that? A diesel-electric hybrid makes much more sense for industrial trucking, and he's 100% right. The guy, it's cool, man. He's a cool dude. Yeah, he's a lumberjack. This guy, oh yeah, he's a big lumberjack, and he talks like this the entire time. Very, very, yeah, you could very much tell he's from the western parts of Canada, bud. Smart, dude. Genius. And I love the Spartan design. It's just a truck. It's just a truck. This shows that we can make, because, dude, it seems like the more technologically advanced a car is, the lesser it gets to be a freaking car, right? Like, we can't make something simple anymore, right? We can't make something like a Detroit, what is it, an 8V60? We can't make something like that. Stuff like that doesn't exist. It either has to be super space age or nothing, right? This truck bucks that trend. That's why I like it. Your father-in-law's a trucker. They get paid by the mile in time. Can't afford to charge for an hour. Yeah, blood. That works if you're like doing regional distribution around a city. So like the Tesla Semi, and I'm not going to sit here and say that I'm not going to trash the Tesla Semi. I think the Tesla Semi is really smart. 48 volt architecture. The Cybertruck motors are derived from the Tesla Semi. First of all, just in case anybody cared. It's using the same 48 volt architecture. The Tesla trucks make great sense for a day cab. So a truck that's, say a train comes in, offloads a bunch of cargo at an intermodal terminal, right? And you're just moving that cargo maybe 40, 50 miles at best. Tesla truck's unmatched. You're not going to match the efficiency. Because you take one trip there, you take one trip back, guy goes home for the day, leaves the truck on the charger overnight, comes back, does the same thing. You can't beat that in efficiency. I'm sorry, you just can't. Makes sense for the city. But if you're out in the middle of British Columbia doing logging, ain't no charging station around there, and you're going to be hauling more than 50 miles. I don't know the answer to that, Jens. So yeah, little bit of a truck tangent, but that's awesome. I think that's cool. It's just a truck. It's completely purpose-built. There's no frills about this thing. That's why I like it. I think more people should do stuff like this. If somebody built a truck that worked like this nowadays, I'm not talking a half-ton quad cab 4-door truck that's basically an SUV with a pickup bed attached to the back. I'm talking single cab, long box truck. You build a truck like that, people will buy it. Absolutely. But we can't do that because we have to sell an $80,000 luxury truck or something stupid. That's why Pepsi got them. Loads from distribution centers to stores on the daily. It makes perfect sense, dude. Yeah. Regional distribution, Tesla truck is unmatched. For district distribution and long-haul trucking, the Edison will eat its lunch. Eat its lunch. Even with Tesla in there, Tesla's working on a 200-amp charger, if I'm remembering right. Or maybe it was 500 amps. I forget. They're working on basically fast charging for the Semi, which, dude, please do it. Like, I'm not saying it's one or the other. I want both of these things. It'd be pretty sweet. Don't act like you don't want a TRX. I like my trucks, dude. I like my trucks. Have you seen the photos of the super utilitarian cheap Toyota trucks? Yes, I want one. Do you know how cool a truck needs to be? And how Spartan a truck needs to be for me to want an import? With that being said, that Toyota truck, the Chirp, I want it. I want one. I want 3. Dude, a $10,000 truck. Sticker price, brand new, $10,000. I'd buy 5 of them. You could buy 5 of them for the price of one half-ton quad cab 6-foot box truck nowadays. Actually, you could buy 8. Like, what? You'd be crazy not to want that, and that's why they don't sell it here, because it would make all those other trucks useless. It is known that heavy elements are from supernovas, so supernova is when there's no hydrogen left. So how does the sun still exist? Sun's got a lot of hydrogen left, Gabriel. A lot of hydrogen. It's got a lot of hydrogen left. We figured that out from the color, believe it or not. You can tell when a star is running out of fuel because it changes color. It gets like blue and white. Actually, our sun emits white light. It just looks yellow to us because atmospheric diffusion from the gases in our atmosphere. True story. That's why the sun at sunrise is like super orangey, but during the middle of the day, it's like yellow. IFT3. Who wants it? Who wants it? All right, let's go. Yeah, Aqualex, genius, practical engineering. I love it, man. I love it. And dude, you know how much I have to, like, it's the same thing with the import. You know how much you have to convince me to like a hybrid truck? I don't like hybrid systems. I really don't. I think it's way too much complication. But in this particular scenario, good idea. Please scroll back. Logging trucks are not long haul. No, listen to what I said. I said logging and industrial trucking and long haul. And, operative word. I understand that, Farm. You don't need to tell me. Yeah, even I'll look at it. Let's read about this, okay? Yeah, I got you. I know logging is very... It's a pain in the butt on the truck. It's really difficult to charge. I mean, you're still dealing with the same problem. There's no charging station out there. You're in a forest, right? That was the gist of what I'm trying to say. The diesel-electric hybrid makes perfect sense, and you can scavenge from going up and down the hill. Also, it needs to be an off-road vehicle. They say, how do I charge this truck? There's nothing out here but trees. Edison's response, use the trees. He's blunt, but he's got a point. All right, anyway, let's check this out. This is SpaceX's IFT3 report on the path to rapid reusability. Starship is designed to fundamentally alter humanity's access to space, ultimately enabling us to make life multiplanetary. The third flight of Starship and Super Heavy. Here, I'm gonna make the text a little bit bigger so you guys can see it. The third flight test of Starship and Super Heavy made tremendous strides towards this future and was an important step on the road to rapidly reliable, reusable rockets. For the 4 R words. On March 14th, 2024, Starship successfully lifted off at 8:25 a.m. Central Time from Starbase, Texas. All 33 Raptor engines on the Super Heavy booster started up successfully and completed a full duration burn during ascent, followed by a successful hot stage separation. This was the second successful ascent of the Super Heavy booster, the world's most powerful launch vehicle. At stage separation, Starship's 6-second stage Raptor engines all started successfully and powered the vehicle to its expected trajectory, becoming the first Starship to complete its full duration ascent burn. Word. Following the stage separation, Super Heavy initiated its boost back burn, which sends commands to 13 of the vehicle's 33 Raptor engines to propel the rocket towards its intended landing location. All 13 engines ran successfully until 6 engines began shutting down, triggering a benign early boost back shutdown. The booster then continued to descend until attempting its landing burn. which commands the same 13 engines used during boost back to perform the planned final slowing for the rocket before soft touchdown in the water. The six engines that shut down early in the boost back burn were disabled from attempting the landing burn startup, leaving seven engines commanded to start up, with 2 successfully reaching main stage ignition. The booster had lower than expected landing burn thrust when contact was lost at approximately 462 meters in altitude over the Gulf of Mexico, and just under 7 minutes into the mission. The most likely root cause of the early boost back burn shutdown was determined to be continued filter blockage where liquid oxygen is supplied to the engines, leading to a loss of inlet pressure in the engine oxygen turbopumps. SpaceX implemented hardware changes ahead of Flight 3 to mitigate this issue, which resulted in the booster progressing to its first ever landing burn attempt. Super Heavy boosters for Flight 4 and beyond will get additional hardware inside oxygen tanks to further improve propellant filtration capabilities. And utilizing data gathered from Super Heavy's first ever landing burn attempt, additional hardware and software changes are being implemented to increase startup reliability of Raptor engines in landing conditions. During Starship's coast phase, the vehicle accomplished several of the flight test additional objectives, including the first ever test of its payload bay door in space. The vehicle also successfully completed a propellant transfer demonstration, moving liquid oxygen from the header tank into the main tank. This test provided valuable data for eventual ship-to-ship propellant transfers that will enable missions like returning astronauts to the moon under the Artemis program. NASA's lunar program. Several minutes after Starship began its coast phase, the vehicle began losing the ability to control its attitude. Starship continued flying its normal trajectory, but given the loss of attitude control, the vehicle automatically triggered a pre-planned command to skip its planned on-orbit reflight of a single Raptor engine. Starship went on to experience its first ever re-entry from space, providing valuable data on heating and vehicle control during hypersonic re-entry. Vehicle control? You sure about that, or? Kidding. The lack of attitude control resulted in an off-nominal entry, with ship seeing much larger than anticipated heating on both protected and unprotected areas. High-definition live views of the entry and a considerable amount of telemetry were successfully transmitted in real time by Starlink terminals operating on Starship. The flight test's conclusion came when telemetry was lost at approximately 65 kilometers in altitude, roughly 49 minutes into the mission. The most likely root cause of the unplanned roll was determined to be clogging of the valves responsible for roll control. SpaceX has since added additional roll control thrusters on upcoming Starships to improve attitude control redundancy and upgraded hardware for improved resilience to blockage. Interesting. Following the flight test, SpaceX led the investigation efforts with oversight from the FAA and participation from the National Aeronautics and Space Administration, NASA. They worked with NASA and the National Transportation Safety Board, the NTSB. During Flight 3, neither vehicle's automated flight safety system was triggered, and no vehicle debris impacted outside of predefined hazard areas. Pending the FAA findings of no public safety impact, a license modification for the next flight can be issued without formal closure of the mishap investigation. Bingo. Good stuff. Upgrades derived from the flight test will debut on the next Starship launch from Starbase on Flight 4, as we turn our focus from achieving orbit to demonstrating the ability to return and reuse Starship and Super Heavy. The team incorporated numerous hardware and software improvements in addition to operational changes, including the jettison of Super Heavy's hot stage adapter following boost back to reduce booster mass of the final fizz. What the hell are you doing? Whoa. Upgrades derived, let me read that again. Upgrades derived from the flight test will debut on the next launch from Starbase on Flight 4. As we turn our focus from achieving orbit to demonstrating the ability to return and reuse Starship and Super Heavy, the team incorporated numerous hardware and software improvements in addition to operational changes, including the jettison of Super Heavy's hot stage adapter following boost back to reduce booster mass for the final phase of flight. That's awesome. So I guess, Dax, if you're still out there, yeah, it sounds like your source was right. But also could be software. But that sounds correct. That's awesome. They're gonna do a Saturn V and jettison the hot staging ring. That's cool, man. Why? They're probably doing this right now because they don't have a better solution. They'll figure out one. They're probably working. Thomas, any of my Starbase tank watchers here that watch this stream as well? There's two different types of hot staging rings, isn't there? They're working on a redesign, aren't they? What are the propellant filters filtering out? I'll get to that in a second, Rem. That's a good question. Honestly, I have no clue since everything is indoors now. I guarantee you we'll see a redesigned hot staging ring in the future. Cannot confirm nor deny. Yeah, okay. Cool, good to know. All right, so. Clogging. Rem, we can get to your question now. That was a little bit quicker than I thought. Clogging. What's clogging? Why is it clogging? These filters are getting clogged with solid oxygen. Yeah, it's not like there's just crap floating around in the tanks and it clogs the filter. They're getting clogged with solid oxygen. Absolutely. That has very much to do with the complicated plumbing of Starship. More complicated plumbing is going to create more complicated scenarios. There's more complicated scenarios for moving that propellant around. And moving liquid oxygen around quickly does sometimes create solidification if you cool something too fast. Or it could have something to do with flow. The filters could also be flow regulators or turbulent flow regulators. Basically, the liquid oxygen can swirl around and it could cool something too fast. Frost could build up on the filter, and that's the end of that. Could be metal shavings, Aranor, but unlikely. It's unlikely that you're going to get metal shavings in some engines, but not others, especially because they're all using the same pickup. This implies that it's something downstream that's not originating in the tank. Because if it was originating at the tank pickup, like inducing metal shavings, right, through the pickup, first of all, there's a filter inside of the pickup right there. Second of all, this seems to imply that these are the filters that are going to the engines, because not all the engines ignited. But not all of them failed either, right? This gets into moving cryogenic commodities around a system that's extremely complicated. There's 33 Raptors at the bottom of Super Heavy. You know, how many of them shut down? You have 30 of them shutting down at most engine cutoff, right? 13 of them relighting to make 16. No. It's 10. So you have 3 of them constantly on and 10 of them reigniting, right? 7 of those 10 that reignite out for the boost back burn after hot staging did not reignite. That sounds like thermal conditioning to me. Basically, when they shut the engines off, they may have had a geysering effect inside of the plumbing. It's possible. There could have been a hydraulic hammering effect there, and the hydraulic hammering effect could have clogged a filter with frost. It's totally possible. You guys ever, if you live in an older structure, you ever shut like the shower off or shut the sink off, and you shut it off and you hear noise? It's not like a straining noise. That's hydraulic hammering. Hydraulic hammering with cryogenic propellants it'll create condensation. It'll create frost. You're changing the temperatures on things very, very quickly by shutting a cryogenic line off. It's only going to take a couple seconds for the line to try and the line to be too much of a temperature differential, right? to have frost accumulate, basically. That's the right way to say that. You're gonna change the temperature of the pipe where you shut the fuel off. And for that momentary second, the pipe could have frost build up on the inside, depending on what goes in there or what doesn't go in there. Remember, where Starship is doing this reignition is cold. It's very cold up there. There's not a lot of anything up there. The temperature is really low. There's a big absence of heat because there's a big absence of matter to absorb said heat. Right? So this could very easily cause propellants to solidify inside of the pipes. Very easy. Yeah. I mean, that... SpaceX is very, very familiar with solid oxygen permeation on things and solid oxygen accumulation because they're using densified propellants. What is the temperature up there? Where Starship is staging, dude, that's like, I don't know, 100,000... I was about to say 100,000 meters. I forget what the staging velocity is, dude. Anywhere above like 100,000 meters, dude... I guess like we would probably say it's like minus 200 C or something. It's something ridiculous, but that's not really a good way to look at it, dude. Because it's not that remember, temperature is the measuring of heat in matter, okay? All right, you're measuring heat. That's what it does. That's what temperature is. Okay? That's like centigrade in Fahrenheit. That's Celsius. Like that's what those are. They're temperature, low temperature is not cold. It's the absence of heat. Okay, that's important to understand. Now, with that being said, up there, right, there's nothing. And this is why scientists use Kelvin. Because absolute zero in the Kelvin scale means there's nothing. There's nothing there to absorb the heat. Nothing. There's your vacuum. It's the absence of matter and the absence of heat, of matter, to absorb said heat. Right? 70-kilometer separation, 105 at boost back. It's freaking cold. Right? So I don't think about it as really being really cold. Space is not really cold. I don't care what anybody says. You see in the movies, oh, space is so cold. You come from a warm planet, Anakin. Space is cold. Space is not cold. Space is nothing. Because we're not just measuring heat in space. You measure matter. There's nothing in space. There is some matter. There's light. You know that. Those stars like our sun kind of emit light. We know that. So there's something up there. But there's nothing that really absorbs heat very well. All right, Dax, see you, buddy. And here's the weird thing. Here's the weird thing, dude. Up there's no matter. So there's no heat. So it's really cold, right? But it's not really cold. There's no matter. But if you have a satellite up there, the satellite absorbs the heat very, very well because satellites are made out of metal. Metal is very thermally conductive. Thermal stuff. And what's inside of the satellite? Computers inside of the satellite. Guess what? Computers are moving around electricity. You move around electricity, you make heat. So you're getting heated by the sun and you're getting heated by your own systems. Cooling thermal radiation systems on satellites, space stations, spacecraft are super freaking important. Probably more important than, like, maybe second to, like, the life support systems, I guess. Like, for human-rated spacecraft. The thermal regulation and thermal radiation on thermal radiative effects. So, like, not the heat shield. I'm talking about, like, radiators. The radiators on a spacecraft, you lose those, you're screwed. You are screwed. You might as well not have oxygen. Yeah, you don't want to lose those. It's a very important design consideration with spacecraft. Yeah, JDG, you love how they point out the high definition live view with Starlink. Hey, it does. It has it. It gave us that view over there, man. Thermal management. That was the right word. Sorry, I was dancing around it. No, Mr. Bond, thank you. So my question is, why not divert some of the heat generated somewhere else to stop frost from forming in the fuel lines? Heat is actually going to make condensation, Rick. You don't want the lines to change temperature. Problem is, a line where you shut the valve and the line's now empty is going to absorb some heat. Why? Because there's not super chilled liquid oxygen in there. That will create condensation. It's not, the engines work fine when all the plumbing is flowing, right? It's when you stop it and you turn it back on. frost will accumulate because you're heating it up. When you heat up the oxygen, when you heat it up, you're going to get condensation on components because you're changing temperature. It happens. SpaceX showed the hot staging ring redesign. Yeah. Yeah, see, they're working on a redesign. So for now, just jettison the Mark 1 design. In the future, they'll have that, a lower mass solution, and it's weird because it looks exactly like Soyuz. It's very strange, man. So they need a better insulative solution? It's possible. So SpaceX's solution seems to be to install more filters. So, okay, I say that this is going to create condensation, and that might confuse a couple of people. How is heating up the propellants going to get it to solidify? Wouldn't it evaporate? Yes, absolutely. Yes, it would. But now you have a pipe that's a different temperature than the pipe that's behind said valve. So, right, you have your pipe going to the engine. You have your valve your flow valve, right, that prevents the oxygen from going in and out. When the engine shuts off, the valve closes. And now behind that, you have super chilled liquid oxygen. This pipe heats up. This pipe is now heated. SpaceX with Super Heavy has to do this in rapid succession. They have to shut the engine off. 5 seconds later, you have to turn it back on. That is this isn't Kerbal. That's a really hard thing to do. That puts a lot of strain on the entire system. So what do I mean when I say that it's going to solidify? Well, normally, rocket engines are thermally conditioned. You basically have your main flow valves, and then you have secondary valves that allow a little bit of propellant to go in. And they basically prime all the lines going to the engine. Now, obviously, you don't want to dry fire a rocket engine, right? That's really bad for it. That'll make an explosion not how you want. And secondly, you want all the pipes going to that engine to be cold. Because if you have a valve that's holding back propellant, you have your engine over here, right? And you have a pipe going to your engine and your turbine impeller inlet. You open that valve real quick. Some of that liquid oxygen, right? Some of that liquid oxygen could evaporate. It could create you could create all kind of thermal transients in there that could cause solidification. It could be the propellant flow. It could be cavitation in the propellants from starting and stopping them real quick. There's 1,000 different things that this could be. SpaceX is clearly dealing with some type of solidification that's happening there, right? They're clearly dealing with that. So their solution is to install more filters at the inlets, right? Right? You're gonna get solidification inside of there, even though it's really, really hot. Going from really, really hot to really, really cold really, really fast you can solidify propellants. It's possible, especially when you don't have convection and you have convection and just conductivity in that pipe. It's possible, and you definitely don't want solid oxygen chunks going into your turbine impeller. That would be a very bad idea. Remember the problem pipes and stationeers? Yep. Yeah, it could happen. Starship is the spiritual successor to N1. Changed my mind. It's like the N1 and the space shuttle had a kid. Yeah, there's a bunch of mass flow which has to be stopped without cavitation or hammering and then restarted in a really short time frame. Yeah. The niddle. N1 and shuttle. The niddle. Oh my gosh. So, yeah, long story short, changing the thermal properties of that pipe really, really fast can cause solid oxygen. It's possible. You could flash freeze the pipe, and that would cause propellants to solidify inside of it. Interesting. What would you try to change? Good question, right? Are they adding filters to smooth liquid flow? I'm not sure if it's keeping solid oxygen out, Aranor, or improving flow. I'll bet you it's a combination of both. and Rig, this is going to kind of deal with your question a little bit. You do not want solid oxygen in those lines. They're called liquid fuel rocket engines for a reason. You have anything but liquid going into those, you're going to have a bad day. Gas goes into the inlet, bad day. Solids go into the inlet, you're going to have a really bad day. Right? So what is blocking the thrusters? Are they freezing? Well, Geek, you know when we watch SpaceX launch, right? And you see like Falcon 9, you see the Merlin 1D vacuum vent pipes, how liquid oxygen is immediately solidifying and accumulating on the end of that vent pipe. That, but with your RCS, because Starship doesn't have a dedicated reaction control system. They're using residual tank ullage pressure because when the engines fire, it repressurizes the system, right? They're using the just vent valves as their RCS to simplify the design. Now, because of this, you have the exact same phenomenon. You have solid oxygen accumulation on the end of the line. And it was enough to block it. It was enough to block the line. And that's why it did that. It kind of spun out of control, right? Now, Rig, you just said, what would I do? Well, okay. Let's think about this for a second. This is not me trying to teach. Let's talk it through. Let's see if we can learn something. SpaceX seems very committed to putting filters into this. Now, okay, so what's the downside of doing that? Putting more filters in adds complexity into the design, no doubt. You're adding complexity, that's more components. That tells me that SpaceX, that is not a seemingly easy thing to fix, right? So that tells me that SpaceX is doing this for a very good reason. The reason why they're doing it is because that's the simplest solution to solving whatever solid oxygen is happening inside of those things, right? Right? So I'm thinking, let me think it through. If SpaceX thinks that is the simplest solution, that tells me that a hardware change is absolutely necessary. SpaceX wouldn't change it unless they absolutely had to. So whatever the solid oxygen problem is something that's very insurmountable. You're going to have to deal with solid oxygen being in the lines due to just how super heavy flies. Like what they're asking it to do. If there was a simpler solution, they probably would have figured out and done it. With that being said, what I would suggest in my armchair rocket scientist mind here, and Rig, here's the thing. There's no way they didn't think of this. There's no way. What I would suggest is don't shut the engines off. Raptor engines are capable of deep throttling due to high chamber pressure. Deep throttle 13 Raptors. Don't shut them off. If you don't shut them off, you don't have this problem. But here's the thing. There's no way SpaceX didn't think of this. All rockets have a limit on throttling. It's not like Kerbal where you can set a rocket engine to 1% power. Even rockets that have the ability to deep throttle, if you get down below 40% throttle, 30% throttle, it'll flame out. It'll flame out. You're just not delivering enough propellants to maintain an explosion to make thrust. Basically, you get a flamethrower, not a rocket engine. Spoiler alert, when your rocket engines are acting as flamethrowers, something blows up that you don't want to explode. Deep throttling rocket engines is a notoriously difficult problem to solve. So, this tells me that SpaceX they've thought about it, and whatever the absolute bare minimum for 13 rocket engines is still exceeding the thrust of 6 Raptor engines on Starship. Basically, if they didn't shut the outer 10 off and just kept, if they kept all 13 engines ignited, they would go to stage and Starship wouldn't go anywhere. Starship would fire all 6 engines and Super Heavy would just keep pushing it because the thrust to weight ratio on Super Heavy at that point exceeds Starship. Because you got to remember, Super Heavy is bigger. It's way bigger than Starship is. But it has like 90% of its fuel expended and 13 Raptors behind it. Starship has a full tank of gas, potentially 100 tons of payload, and only 6 engines. There's no way the TWR 13 Raptor engines, even deep throttled, is going to be below 6 engines at full throttle with a full tank of gas. Not a chance. See what I mean? That's an insurmountable problem. If they could have kept 13 engines firing, they already would have done that. They have to shut those engines down to get Starship to get a clean separation for hot staging. So now this proposes a problem of immediately stopping and immediately restarting your engines. They need that thrust for Super Heavy to be able to get it back to the launch site. Higher TWR on first stages is always more efficient. Even though your first stage has more delta V, the name of the game for efficiency with first stages is how quickly it can get the second stage up there, and that favors high thrust to weight. High thrust to weight gets you a more efficient performance with first stages. Higher energy first stages, long story short. That's why Super Heavy has like 70 meganewtons worth of power. Like way more than any other rocket needs. Because TWR is the name of the game for efficiency for your stage. What about a 9-engine ship? It sounds similar to a problem. Yeah, a 9-engine ship, erudite maybe, but now you're going and changing the plumbing again. Who knows? You might have that problem again. You know what I mean? Or figure out a solution that makes it so you don't have to light all 10 of the ring there. Maybe light 5 of them. Maybe 6. Shut down, I don't know, shut down 25 or 26 engines, right? And leave the other 9 to just do their thing. 6 on the inner ring, 3 on the center, so you don't have this problem during boost back. That would be my solution. That's a good idea. Wait, is that why Super Heavy did a RUD in the sea because of frozen RCS? No, that's why Starship did a RUD during re-entry, Byron. Super Heavy had solid oxygen clog the oxidizer lines to 7 out of the 13 Raptor engines that were required for boost back. And they were unable to be restarted because that solid oxygen basically sealed the plumbing. And the computer rightfully realized that you don't want to put propellant, you don't want to try to pump propellants through a clogged line. Anybody that's ever had their pipe bursts in winter knows exactly why you don't want to do that. Tessa turbofans. Huh? What are you saying? It's turbofan engine fuel systems. When a plane is coming down pretty quickly from cruise direct to landing, it was found that small amounts of water in the fuel was freezing into a slush where normally it would melt on the warm water. So ice pass through, just sticky enough to cling to the sides of the filler tubes and cause fuel starvation. Yep. Thermal transients, such a pain in the butt, dude. You guys want to know why valves are such a pain in the butt in the aerospace industry, planes, rockets, whatever? It's because of temperature differences. Because a valve doesn't, material science doesn't do very well. Metal doesn't do very well when it's like minus 200 C on this side and 70 C on this side, right? Like that's a huge difference in temperature. That's why valves are so tricky to get right. Yeah, erudite. Yeah, not let me see if you shut down. Yeah, but see, okay. Now that I'm thinking about it, you still have to restart those engines. If you only shut down, you don't shut down 10 engines, or you don't shut down 30 engines at engine cutoff, right? You shut down 26 of them, right? You still have to relight those engines to get the boost back performance that you need. Because once again, the name of the game is thrust to weight for first stages. You want to make a more efficient first stage? Give it more thrust, more boosters, baby. Any Kerbal player knows that. Am I right? More boosters. That's more efficiency for your first stage. The faster it gets your second stage up there, the more efficient it is. I wonder if the engines are pulling enough negative. I wonder if the engines are pulling enough negative pressure at the inlets to get some solidification. That's my guess, dude. It could be turbulent flow. These fuel filters could be it could be preventing cavitation, thermal differences in the pipe. I'm telling you, this is a thermal problem because frost wouldn't accumulate if there wasn't a thermal problem, right? They got to find a way to thermally condition these engines fast. We're talking, like you said, like blue, it's a 5-second window. You know, because those engines shut off, the booster flips around, and then they immediately refire. That's very difficult. That's a very difficult problem to solve. Just put a turbocharger in it. And rocket engines already have turbos. They have a gas generator. That's a gigantic turbo. It's just it's a jet engine attached to a fuel pump. They already have turbines in them. How about putting dividers in the tanks on the booster? They already did that. There's a header tank in Super Heavy Journey for that exact reason. That's already been done. I don't know, I'm a high schooler. Yeah. Yeah, we can tell. It's all good, man. Yeah, we know. Sorry, I'm just busting your chops a little bit. Sorry. Main tank, you're talking about Starship. No, I'm not. Super Heavy and Starship both have header tanks, dude. For that exact reason, dude. Oh yeah. Propellant management. Yeah, Super Heavy has header tanks, dude. That's how it basically has a plenum. Plenums are usually used in pneumatics, though. There's a plenum. There's a small catch tank, like a day tank on a boat almost, inside of the main fuel tank. Yep. You know what the interesting thing is, fellas? The N1, the failed Soviet moon rocket, had the exact same problems. Yeah, interestingly enough, filters kept getting clogged because of the complicated plumbing on the N1. That's why it didn't work. Same as Falcon 9, it also has a header tank. Yep. I know, they need to make the internal surface like that metal plate from the 90s that was billed as the freezer food defroster. And one had it happen at launch. Yep. It's interesting because their solution, Hellfish, their solution as well was to put more filters in the design, which has me think that it's not about FOD contamination. Putting filters in the design is filtering out solid oxygen. Yeah, it's filtering out something that can't be filtered out on the ground. Makes sense. Updated timeline. Yeah, this is a really, long story short, it's a really difficult problem to solve because no one's ever tried to move a 22-story building around in space like that. Super Heavy's equivalent of a building with 22 floors on it, by the way. That's a big object moving around in space. And then you have to make the rocket engines, arguably the most complicated rocket engine ever devised by man, work on the bottom in rapid succession. So this is coming from Craig Mauser. Side-by-side comparisons of IFT3 and IFT4 timelines. Can they use the heat from entry to heat the valves? Well, where it's doing the boost back burn long, there's no heat. There's nothing. That's the problem. The vacuum is probably causing solidification, if I had to guess, because of insane temperature differences from a line being cryogenically primed and not from engine cutoff. Stopping and starting a rocket. Long story short, starting and stopping a rocket engine is a difficult problem to solve down here. It's an extremely difficult problem to solve up there. Yeah, no doubt that SpaceX will find a solution, though. They'll figure it out. The filters might be the solution. We'll see. How hard is solid oxygen? I don't know, Hellfish. I would guess the consistency somewhere near ice. The crazy part is that they have it working fine for getting the skyscraper to space. They're just running into complications getting the skyscraper to turn around. I feel like if you add more filters, it just creates more turbulence and you can make the problem worse. Am I wrong? These filters are probably, see, there might be flow filters, JDG. That's the thing. It could be for flow. The filters might not even be for filtering out solid oxygen. I'm sure they have those in there, but it could be a filter that's designed to create a certain type of flow to flow into the turbine and inlet correctly. That's possible. I'm sure there's another name for it. SpaceX might be referring to it as a filter just because, once again, like with Starliner, this stuff's hard to understand. But who knows? All right, let's see. What are the timeline differences? They're shortening up the fuel flow here. Yeah, like a bend in the pipe is going to create turbulence. So if you have a flow filter, like if the pipe elbows and then goes into the rocket engine, you'd want a flow filter after that because you don't want like a swirling propellant going into a swirling impeller. That would be bad. That would be, it needs to be nice and uniform going in. Faster filling for sure. And yeah, see, they switched it. They switched to methane first, then liquid oxygen. And before they were doing ox, then meth. Yes. Booster LOX load underway. Yeah, and they're doing ship first, dude. Interesting. Interesting. And it is laminar flow. Laminar flow applies to all fluids, dude. Yeah, just clean, uniform flow. Liquids and gases, dude. Raptor begins engine till 1940. Booster prop load complete. Ship prop load complete. It's interesting. The booster, despite fuel starting, dude, that is an insane amount of propellant to move in that amount of time. That's crazy. The ship starts commodity fill 10 minutes before the booster, and they both get done within a minute of each other. That's crazy, man. Are we going to do Fallout today? Yeah, probably. It's not going to be long, though. Maybe an hour at best. Dude, sequencing 33 engines in 3 seconds is insane. It's impressive, dude. Flight timeline, what do we got here? Liftoff, Max Q, Booster Miko, Super Heavy Miko. They changed the name. Hot staging, boost back burn, shutdown, hot staging jettison. Oh, that. Huh. How does the booster structurally support ship first fueling? Because it's made out of steel and it's really freaking strong. 4 mil thick stainless. It's 4 millimeter thick 304X stainless. That's really strong stuff. Yeah, Crafty. That's how I was worried about that. But then I realized that, it's not a balloon tank. 4 mil thick steel is ridiculous for aerospace. 4 mil thick anything is really thick. That, like, especially if you're choosing stainless as your material of use. Yeah, long story short, it's made out of steel, not aluminum. If it was aluminum, oh yeah, it would, Yeah, there's just slight adjustments for the timelines here, but yeah, interesting. An exciting landing. That's what that says. Do you know how much computing power Falcon 9 has? I mean, like, the Saturn had 36 kilobytes. It has more than that, Violent. Falcon 9 actually uses Unix. It's a Unix system. Yeah, believe it or not. Yeah, well, Linux-based. Sorry, not Unix, but you get what I'm trying to say, right? I know the difference. I know that They're the same, but they're not. I get it. Right? Software people, don't kill me. I swear. I swear. We're good. We cool? Falcon 9 uses a Linux-based system, and they have 3 processors in RAID, basically. Yeah, they have 3 off-the-shelf processors. It's something that they could. We don't know exactly what it is. I think they're Intel processors, but I could be wrong. Slowly resheaths the knife. Yeah, sorry about that. Sorry, I realized what I said like 2 seconds after. I'm like, no, no, please don't kill me. I swear. Like, don't do that again. Might have missed Ship 29 doing a landing, flip, and burn in that photo unless you covered it earlier. Flame Trench is starting in about 2 hours, Journey. Yeah. Why Linux? Do you want your rocket to be running on a Windows operating system? Just saying. Just saying. Your rocket's launching into space. Hey, we got to restart your computer for you. It's time for an update. Oh, you know. Do you want your rocket running Windows? I don't. Windows update mid-flight. It would happen. It would happen. You know it would happen. Clippy, it looks like you're trying to launch a rocket. Do you need help? No, Clippy. Oh, it blew up. You suck. Stupid Clip. I mean, I'm just saying. Just put it out there. Yeah, your settings have changed back. Yeah. We changed your settings back to how they were before when the rocket exploded. Oh, it exploded. Hey, I see your rocket exploded. Do you need help? Jason, you're learning EFI development. It is OS-less. I would ship that. Would I ship that to space? Not without something else. EFI development. Cool. I see that Edge is in your main telemetry viewer. Why are you using something else? Wait, flip and burn from Ship 29? Hold on. Oh. Yo, thank you for pointing that out. No way, dude. No belly flop for this one. At least with Windows, you would at least with Windows, you would be guaranteed to have telemetry enabled at all times. Ship 29 won't make it there, so no need to get excited. Spicy. Thomas, I'll say it once, I'll say it again. Unless this suborbital trajectory is coming down somewhere further downrange than like Australia, I highly doubt this thing is going to survive. That is my armchair rocket scientist opinion. I really hope to be proven wrong by SpaceX. I would like nothing better. Most stuff that flies on this re-entry trajectory does not survive. Most things. If they can somehow get Starship to do it, I'd be very impressed. But most things that fly this re-entry trajectory, most things that have flown this re-entry trajectory in the past have not been made out of steel. So there's a variable here. Clearly SpaceX thinks it'll make it through. The trajectory that Starship is going to fly on is very similar to Starliner with Centaur, with the dual-engine Centaur disposal trajectory, or a more well-known thing would be the Space Shuttle's orange tank. The orange tank was disposed of before the shuttle got on orbit and purposely re-entered over the Indian Ocean to ensure that it would burn up. It's a very steep re-entry trajectory. So, like, let me put it to you like this. If you had a capsule fly on that re-entry trajectory, it would not survive, even with a heat shield. You put the shuttle on that? Nope. Nothing would come back. Maybe a couple of tiles. It's a very steep trajectory. The margins here are very, very small for re-entering. But then again, what we know about re-entering is all based off of ships that are primarily made out of aluminum, which is completely different than stainless steel. So let me put it to you like this, Thomas. If it makes it through re-entry, I'll be very impressed. There's not many things that could fly that trajectory and make it to the ocean in one piece. What about an Apollo capsule? Nope. It would pop like a zit. Not. Wait, what? Why? That doesn't make much sense. The Apollo re-entry was much more aggressive. Do you guys go right to gotcha. Do you guys even know about the Apollo re-entry trajectory? You know, they bounced off the atmosphere to mitigate thermals, right? They skipped off the atmosphere to make sure that they didn't flux too much heat into the heat shield fast. Yeah. If too much heat into the heat shield too quickly will burn the heat shield completely off. And then you have no heat shield. That's bad. Give me 1 second. Like a rock on a lake. Yeah. You're fluxing way too much heat into the heat shield way too fast. It's not that the heat shield couldn't take that amount of energy. It's that it can't take that amount of energy fast. Your rate of heat transfer is the problem here. Now, here's the thing, man. Maybe the Apollo capsule could do it. I wouldn't want to be on it if we were going to test something like that. But Starship is designed to return from trans-Martian injection. Or trans-Earth injection from Mars, right? I think that SpaceX is insisting on this steep re-entry trajectory to basically trial by fire their thermal protection systems. So they can learn more about that for maybe in the future when a Starship comes back from refilling HLS out at the moon. I can dream. I can dream. Okay. Flight 4 predictions. Well, that's what we're talking about. I tried re-entering from the moon in 100% steep trajectory. I'm not a smart man. Do we know what altitude it broke up? They said it was 65 kilometers off the deck. Honestly, dude, Starship, this thing, IFT-3, re-entering backwards, made it through peak heating, which is pretty freaking impressive, dude. That's pretty good. It flew Raptor first into plasma, and it made it past peak heating, which is pretty freaking cool. That's impressive. So, you know, that maybe there's something to this stainless steel stuff, you know? That's pretty freaking cool. Refilling HLS at the moon. Thought HLS had to return to Earth. I don't know. Crafty, I'm basing this off of contingency. Maybe. I said maybe. Maybe in the future they switch it to refueling at the moon. Doesn't make sense to take HLS all the way back here. Send another Starship out. Especially since Starship was built with the thermal protection system in the first place. You don't want to refuel. HLS wouldn't have enough fuel to get all the way back to low Earth orbit. If it did, I'll be very impressed. You know, refill it 15 times, send it out to the moon, land it on the moon, have it be on the moon, come back off the moon, and then circularize back around to Earth. I highly doubt it has enough fuel to do that. I would love to be proven wrong, though. It makes much more sense after the first time you get that thing out there to refuel it out there. Because there's no need to pay, you don't need to, it doesn't make sense to pay for all the mass to come back to Earth orbit just to fill it up to get out of Earth orbit again and also go to the moon. Why don't you just refill it so you can do multiple moon landings at the moon? This is all theory on my part, though. It's all theory on my part. Once again, I just play Kerbal, all right? I just play Kerbal. That's all I do. Okay? That's all I do. Just play KSP. Okay? Okay? All right? All right? All right? That's all I do. Is re-entry heat really necessary, or is it possible to return without? Violent, yes. What you just asked is saying, is a boat getting wet a requisite for it floating in water? Yes. Yeah. There's not, I mean, there are ways to get around it, dude. If you found a way, so say you were on orbit, right? And you had a fully fueled Starship sitting on orbit. Could Starship get back down without a thermal protection system? Yeah. You would use all of the fuel inside of a fully fueled Starship, right? Yeah, it could probably do it. Basically, you would slow yourself down enough to where the point of atmospheric interface is not, your velocity at EI is not very high. You basically drop like a brick. But in order to do that, you need, rough napkin math, you'd probably need 4 to 5 kilometers a second delta V to even do that remotely in any way, shape, or form. Because, okay, so let's think for a second. You have Starship with no thermal protection system. What also is similar to Starship that has no thermal protection system that also wants to come back? Super Heavy. Super Heavy doesn't have that. Doesn't have any tiles. It doesn't need it. Stainless steel can absorb all the heat. That's why it doesn't do supersonic retropropulsion. So in my mind, you'd have to get Starship somewhere similar to a suborbital trajectory that is somewhere near Super Heavy. Now, what was Super Heavy's staging velocity last time? How fast did it go? It went pretty dang fast. I don't know, how fast was Starship going during IFT3 at staging? Let's take a look.
We're a minute away.
All right, let's take a look. So there's staging right there, right? Speed, 5,600 kilometers an hour, okay? Altitude, 73 kilometers, okay, for the first stage right there. All right, so orbital velocity. SpaceX is using kilometers an hour, so we'll just use kilometers an hour. Orbital velocity is 27,100, give or take, around 27,000 kilometers an hour. If you wanted to try and re-enter a vehicle with no thermal protection system, all right, you would need to decelerate 22,000 kilometers an hour. You would need enough delta V for that. So like I said, 4 or 5 kilometers a second easily with delta V. That doesn't make any sense. Why doesn't it make any sense? Well, are 30,000 composite tiles more mass than a full tank of fuel? No, this is significantly lighter than this. Use this to get back down, right? You could re-enter with no thermal protection, sure. You would need to find a way to get rid of that kinetic energy that you have. 27,000 miles an hour. Sure. You could do this in KSP if you want. If you want to test it, go do it in KSP. Same thing. I mean, re-entry in KSP is very, very forgiving, to be honest. Every part in KSP is made out of steel. Like every metal piece. There's no aluminum here. But you could do this in KSP. Sure, no problem. Hey now, if we were in Star Trek and could keep yourself moving forward to stay over the same point on the ground while descending slowly, it'd be no re-entry heating. Yeah, JDG, that makes sense, but we got a little bit of a problem here. The problem is that this isn't Star Trek, but your weak link is. This is Earth. I'm sure on some planet your martial arts style is very impressive, but your weak link is. This is Earth. How about try my nuts to your foot style? How'd you like it? Face to foot style. Oh, I'm bleeding, making me the victor. We have purposely trained him wrong, as a joke. If you got a butt, I'll kick it. I apologize for Wimplo. He is an idiot. You'd need a gazillion barrels of fuel that way. I mean, yeah, no doubt, dude. How cool would it be maybe in the future? SpaceX bringing an HLS back to LEO and then refilling it enough times to just supersonic retropropulsion its way back down to the surface. You know, that would be pretty cool, man. I'm not gonna sit here and tell you boys that I wouldn't want to see that. You know, like, I'm sorry, that'd be pretty sick. You know, yeah, tiger, lander, birdie. Just make it out of Inco? I kid. But on a more serious note, do you think there's an advanced metal that you could make the skin out of if you didn't care about costs and re-entry profile that would make a thermal protection system free unpowered descent possible? You could always build the TPS into the structure of the vehicle, Aqualex, but yeah. Like an integral thermal protection system, it's possible. It could work. You'd still have to deal with some ablation unless you're using tiles or something, right? Tungsten, too high mass, Rem, but it should. I mean, tungsten melting point, 6,100 Fahrenheit, 3,400 Celsius. The problem with tungsten is that it's extremely high density. So the only way, yeah, I mean, it's possible, sure. I think tungsten is too high mass, though. Its density is 19.25 grams per cubic centimeter. That's really dense. That's almost as dense as me. It could work. 6,000 Fahrenheit would be enough. It would be enough. So, you know, you have like an aluminum rocket with a very heavy thermal protection system on it, like the shuttle, or you have a stainless steel rocket with a lighter thermal protection system on it. You know, what's the total mass of that? If you just made the entire fuselage out of tungsten, sure. I mean, but I honestly think that that's too easy. And if somebody has probably done some material analysis on this at some point, and if this was that easy of a solution, it probably would have been done. If it's low-hanging fruit, tungsten is too dense. You'd cook anything inside. It really depends, John. It depends on the shape. It depends on the shape of your spacecraft if you'd cook anything inside. I mean, you could always mitigate it with the life support systems, which is also the air conditioner, right? You could do it. But I would need to know more. In this particular case, my material understanding here kind of fails me. I'm just reading the Wikipedia page. So what do I mean by that? I don't know how tungsten deals with heat flux or metal or conductivity. Like, we just know we know its density and we know its melting point. You know, it really depends, dude. Tungsten is so ridiculously dense that if you didn't have uniform flow over the vehicle, it would probably heat up other areas. You'd get non-uniform heating on your integral TPS. That would cause problems. Because if your thermal protection system doesn't distribute the heat very well and you have it on an integral spaceship, it's part of your structure, well, guess what? Now you just melted some of the structural integrity on your spacecraft. That doesn't seem very smart. I would be more worried about that than frying what's inside. But once again, I don't know that much about tungsten. I know you can make bullets, cannon shells out of tungsten. You make sabot rounds. And it will go through things because it's tungsten. Employed in scale, Aqualex, sure, but I also, from what I understand, tungsten is extremely hard to work with, which is why they just make two, like, arrows. Basically, a freaking arrow out of it. That's what a sabot round is. It's just an arrow that's shot out of a cannon. Read about sabot rounds. They're really cool. SABOT. It's pretty... I mean, Aqualex, I know you know. That's for everybody else. Yeah, good questions, good conversation. Some of these words are confusing me, but you still got me. All right, Tony. Sweet. If I'm speaking too much nerd, you let me know. I'll try to explain it easier. You got to let me know though, because if nobody says anything, I'll just assume you guys understand what I'm saying. Tungsten is terrible for re-entry. Titanium alloys are a little better, but still run into problems at those temps. Yeah, Blue Flare, my guess, and this is a huge guess off of what I know about tungsten, is that you wouldn't be able to distribute the heat. That tells me that tungsten has awful heat flux, which is probably why they make cannon rounds out of it. Awful heat flux would favor your cannon shell going through things. EJ, when don't you speak too much nerd? When I ask chat if they don't want me to, man. 90% of the time, I have no idea what the crap you're talking about. Oh, okay. Frick you, and frick you. Who's next? And man, you got your wedding band made from the stuff. Tungsten. I didn't want it to get scratched. What I didn't expect is that you have a natural glass beaker on your finger. Topic change. Are you covering Electron at 315 or just skipping it? I gotta sit this one out, Thomas. In-laws are here, dude. We'll see. We'll play it by ear, okay? Boron is solid up to 2000 C and fairly light. Yeah, isn't boron also like super reactive, Yannick? Yeah, mine's titanium. Titanium, like they use on the space shuttle. The implication there is that the whole space shuttle is made out of titanium, which it's not. Its landing gear is. Landing gear needs to hold up 60 tons of orbiter. Yeah, that's the strong part. Boron, that sounds like a... Wait, what'd you call me? Well, then I can tell 90% of the time I pretty much know what you're talking about. Does that make me a nerdy nerd? Yes, absolutely. I'm here to learn, everybody, not to make out with you. Go on with the chlorophyll. No, I will not make out with you. Did you hear that? Chat wants to make out with me in the middle of a stream? I mean, we got Rocket Man up there talking about God knows what. All chat's talking about is making out with it. I'm here to learn, everybody, not to make out with you. Go on with the chlorophyll. Yeah, of course, Grabshock. I try. I try my best. Oh, an unobtainium, yeah. Boron is a brittle, boring element. Dude, am I not going to get enough puns doing a cast with Sawyer in an hour or two? Like, are we not going to get enough puns? We just got a pun here too now, huh? Yeah, we just got to do it here? Give me your damn pun tokens. Maybe boron carbide. I'm sure there's Hexa, I'm sure there's people working on different alloys for thermal protection. Metallic heat shields are definitely a thing that NASA has looked into. We just don't really know what came of it. Have you heard of the line? Yeah, Yavin, I know all about the line. Okay, all right. Yeah, they started to work on it. They started construction. It exists. Add time. All right, let's roll D20. Tessa retrieved add time. So here's what we do. Every time add time gets retrieved, I roll D20, chat rolls D20. Whoever wins, if I win, no ads. If chat wins, you run ads. Tessa rolled a 19. Have I mentioned that I don't like you, Tessa? Have I mentioned that recently at all? All right, tell me when they're done. I'm just gonna sit here. Don't worry, you won't miss anything. It's just... Did you forget that I use that just to burn points? Yeah, but I really enjoy making you look stupid.
Discovery,
sorry, man. Tim McLagan, no ads for me. 4-month resub. Nice. There was always rhenium, or you could just grow a diamond monocrystal in the shape you need. Oh, yeah, that last part sounds really easy. Repost. Just make the whole craft out of hylixes. Sounds rough. Sounds good to me. Obsidian. Hey, have you heard of the pulse plasma rocket? Yep. Mm-hmm.
Discovery.
Aranor, 18-month resub. Fist is with the 88. For just 71 payments of a monthly sub, you too can understand EJ. Did you see the MIT study of metals under extreme impacts? I have not seen that, Gujar. I'm sure it's good, though. I'm just telling him that so he makes it good.
Discovery.
Red, I lurk here just to look smarter. Actually, Grab, dude, sometimes, because I get super deep into thought with this stuff, sometimes I go back and watch VODs, and I kind of hear the VOD out of context. I'm like, wait, what the hell was I saying? What does that even mean? And I go back and listen to the whole thing. I'm like, oh, yeah, that's what I was talking about. But if you, like, at face value, I'm like, I don't know what the frick I just said. I don't know what the hell I just said. What just came out of my mouth? Damn, that's a good answer. All right. Scientists have discovered that when metal is struck by an object moving at a super high velocity, the heat makes the metal stronger. The finding could lead to new approaches to designing materials for extreme environments, such as shields that protect spacecraft or equipment for high-speed manufacturing. When do we go back to workers and resources? I'm planning on doing that soon. Just, yeah, let's, I want to get Fallout 4 out of my system. That should be done, Mutter. Thank you. You guys want to play Fallout for an hour? I don't know how we're going to manage to play it in an hour, but I have to go start to get ready for the Flame Trench, where all your weekly combustion byproducts end up. Don't worry, you won't have to go anywhere for that. Watch this before Fallout, Uncanny Valley. And I don't want to. I don't like you right now. That link doesn't exist, Nova. What do you think of Shenzhen.io? I don't know what that is, Pigeon. That's a game, isn't it? I don't know what it's about. I forget. Classic America approach. Let's shoot it a bunch. It'll make it stronger. Hey, man. Us wanting to blow things up gave us the most bountiful power generation source ever devised by man. All right? Okay? Sometimes wanting to blow stuff up and adding more boosters and more struts is the right thing to do. Sometimes shooting it is the right thing to do. Just blow it up. All right? Hey, we learned a lot from doing that, okay? Here's the link if you want to read it. That's also 404 in Gujar. Anyway. So what's this? GTA 5 next level graphics enhancement with stunning ray tracing showcase on an RTX 4090 Ultra. Why do you want me to look at this? It has nothing to do with what I'm trying to do. You just trying to distract me all the time? What's the matter with you? The frick's the matter with you?
Discovery, going throttle up.
Yeah. Is that the economic patch, Nova? Good. Good. I have not read about that yet. I will do that over the weekend, okay? What is this? This is from 24/7 Gaming. GTA 5 next level graphics enhancement with stunning ray tracing showcase on RTX 4090 Ultra. Okay. Gotta admit, it's real Uncanny Valley. Car is too shiny. The specularity on that shader for the car is way too high. And the light diffuse is it's too sharp on that car. Unless that car just freshly got detailed. That looks real nice. That looks really, really pretty. Also, why is it raining in California? I know, recently it's rained more. I get it. Shut up. It was a joke. It was an old joke. It aged kind of well, all right? Jeez. Boom. Yeah, but considering it's GTA 5. Dude, I'm not going to sit here and pretend. Like, Rockstar admitted right... I remember when GTA 5 first came out on the PC, everybody complained that cranking the graphics all the way to high... Basically, a lot of the graphic settings in GTA were designed for systems that didn't exist yet. So GTA would age gracefully. Rockstar said that when they released it. They designed the systems here to be able to scale for a couple of gen down the road hardware. So basically GTA 5 was built for a 4090 10 years before 4090 even existed. It's built for this. Rockstar's done that many times. They did that with Red Dead 2. Red Dead 2 as well. Sorry. I was about to say Red Dead 2. Whatever. You would have understood. Shenzhen IO's Polybridge, but for logic circuitry and firmware. Cool. Yeah, the specularity on these cars is much too high. You'd get more light diffuse on the paint in an overcast condition like this. Trees look great, though. Looks really good. The cars are way too shiny. Like, way too shiny. It's close. It's close, Tessa, but it's not exactly right. Okay, see, look. In these type of overcast conditions, the way the light is being cast, it seems like there's a lot of clouds in the sky. But that mountain looks way too clean. You'd see fog in between the mountains here. There would be overcast conditions. You wouldn't be able to see the top of the mountain in this picture. That's why that looks completely wrong. Look at that mountain. Just kind of sit there and look at it. That looks completely wrong. It looks like it's a sunny day. Also, nice Roadmaster. Repeating texture. See the bricks? Repeating texture. I saw one wall, and then I saw another one that was exactly the same. How do you know it was the same? Was it the same wall? It's a glitch. It's pretty good, man. Yeah, no, you're not wrong. Oh. Not the demon. See, once again, buildings. Those buildings are way too shiny and way too clean for overcast conditions. Let's see. Let's see till where it gets sunny. Ah, yeah, see. That's what I'm talking about. That looks right. See how it's kind of foggy? How is it that when the sun's out, it's foggy, but when it's cloudy, it's not? That's weird. Yo, was that a Series 3? Hold on. Yeah. Defender. Nice. Also, there's some disgusting mid mapping going on right here. Watch, guys, watch the inner corner of the terrain right here. It looks like it's pulsing. That's because of texture loading and unloading. It's called mid mapping for texture optimization. Watch the right side of the road when he goes around this corner. Watch, right here. Did you see it? The mid mapping though. Oh man. The ground's pulsing. The lighting, see the lighting in these conditions? That is what cruising on PCH at sunset looks like. That's pretty damn close. Yeah, that's pretty damn good, actually. That is a Pacific sunset. The lighting is exact. Yeah, that's exactly what it looks like. Nice Thunderbird. The rocks are too flat. Yeah, it's because they normal map them. That's why they don't have a lot of topology for optimization purposes. It's less geometry to render. It looks like it's bumpy, but it's not. Very nice. Terrain cuts, yeah. Where's the netting that should be over that? You know what I'm talking about. This game makes you miss Los Angeles almost. I don't need to miss Los Angeles. I'll go to Lompoc, man. It's out in the woods and there's rockets. Okay. Another Roadmaster. Nice. JK. Is the AI driving accurate? Yeah. Yeah, there's not enough distortion here. There needs to be more atmospheric haze. Just a little bit. It's close, but it's not exact. It's too clean. 3 out of 10. No CVPI. Yeah, I like you. This is Thomas. I like you. We're friends. Yep. This is Tesla Link. It's GTA with ray tracing, showcasing like a 4090. What a 4090 can do. Don't get me wrong. It's pretty. It's not uncanny valley, Tessa, for me. That's because I'm a 3D artist, like by trade. I can see all the problems with this. But see the haze? That makes that look right. That looks like the Santa Monica Pier. That's pretty damn close. But it seems like in your immediate area, there would still be a little bit of distortion here. Crown Vic Police Interceptor, guys. Bird. That looks nice. That is exactly what that looks like on this road, looking at the Santa Monica Pier. That's really, really nice. It's pretty good, man. Yeah, pretty good. Nice. All right, that's going to conclude space news, but don't worry, we'll be talking more about space stuff for the Flame Trench happening in about an hour. And yeah, we'll play Fallout to tie us over for a second. Sorting out mass amounts of loot because I'm a hoarder. There we go. That's a good title for the stream. NSF Flame Trench at 5 p.m. Eastern. Changing the title over on the YouTube side of things. There we go. Yeah, Boone, I did that yesterday. I might have time for a loot run. I don't think we do, but if we just chill around Sanctuary and decorate some things or build out some houses. Ship 26 is best ship. Yeah, whatever. You can be wrong. It's fine. Yeah, there you go. Yeah, man. Yeah, exactly. I know you'd know it. No. Yes. Your beard is growing. That's usually what happens, man. Jacob likes food. What's up, man? Hey, Jay, long time no see. I was tuning in pretty regularly for the KSP2 streams, but life got busy. Saw you were live and wanted to drop in and say hello. Hey, Jacob. Yeah, I remember you. Yeah. Cool. Is there a Fallout 4 mod that adds ballistic rocket-launched mini-nukes? You don't need a mod to do that. You have to get link permission from mods, Datao. X-Plane 12 weather? Oh, nice, dude. Very cool. Yeah, that looks really good. All right. Let's get the tunage going. There we go. Music. Give me 1 second, dudes. I'm just checking in on NSF. Okay. Any place I can post pictures of your Vault 88 contraption? Yeah, Pigeon. The problem with the Fat Man is that you're usually going to blow up something that's useful to you. I was playing RimWorld all week and was so confused for a second. Dude, the RimWorld soundtrack works great if you're trying to set up a settlement in Fallout 4. It works real good, man.
I've never lost anyone before.
Hi, Ada.
This failure is new to me.
All right. Seems to be seeming well.
Please, just... I need to be alone right now.
Shut up. Didn't know the link policy, thanks. Tessa, can you give link permission for Girl Made of Cheese, please?
It's a pleasure to serve with you, sir.
Just so long as this game doesn't have the burrowing sound effect like Workers does. No, I don't think so. Yeah, girl, go ahead and post it. I'll have him ready for next time. Sorry, don't have him now. Oh, it's all good. Don't worry about it. It's reg ad, Tessa. So yeah, we ran into some strangers that tried to pick a fight with us, and we, you know, they didn't win. Yeah, they didn't win. We liberated their weapons from them. All right, so that rifle needs a stock. We need adhesive. Over encumbered? Really? What the heck's taking up all... Yeah, we should probably sell that. Put it on the table there, so I know where it is. We need adhesive. So what I'm doing is I'm building Minutemen standard combat rifles. This is I'm gonna play into the I've been playing into the Minutemen on this save, but we're going to make the Minutemen not some guys that go around wearing something that looks like from the Revolutionary War. We're gonna get kitted up. See what I'm saying? Gonna get kitted up. I want to be able to take on the Gunners, the Enclave, the Brotherhood of Steel, and the Institute all at the same time. We're gonna we're gonna make the Minutemen awesome. Did you nab that XO1? 58, I don't have it yet. Remember, if you get level 40 is a scrapper perk, and level 41 was the science. Yeah. Oh, yeah, being able to call in a target. I think that was something you could do in another Fallout game. Did you get the Silenced Railroad pistol yet? No. I don't have that one, mate. Grabshark, have you seen this thing? This rifle? This frickin' thing. Take a look. The Amputator. 99 kinetic, 100 nuclear, fire rate 40, range 107, accuracy 79, weight 16, value 550, with a bullet explode on impact 15 point AoE. We call it the Amputator because that 15 point area of effect chops people's limbs off. It looks like we're shooting somebody with 277. It just death. Just death becomes of you. And also, the 45 that we're shooting is nuclear tipped. Yeah. You got a minigun that has that, Jand? Oh, man. All right. Okay, here's what we'll do. Let's go get that power armor. Let's go get that XO1. It should be... it's at that three-way intersection right there. But in order to go get it, I need to venture out without combat armor. I don't know if we should do that, to be honest. That could turn into a chore. Alright, let's go. Do it. I wish I had a pair of combat armor, but I gave that to all my caravanners. All my caravanners are kitted out with those Minutemen SCRs, the combat rifles with the extended mag, and full suits of combat armor. Did you do taking the castle? That unlocks calling in artillery and placeable settlements. Oh, that's right, Chand. I have not taken the castle yet, though. We don't have the cannons yet, but we could have the cannons. That's right. Yeah, and Otan, there's a thing that you can do. The Minutemen have artillery, and you can call in artillery strikes. Level an entire city block. Called in an artillery. They quit subtle tactics. They called in an artillery strike. Level an entire city block. Still got the shovels.
I've never lost anyone before. This failure is new to me.
Yeah, Oten, I recalled vaguely that you could do something like that. I wasn't sure if it was in this Fallout or another one. Thanks, chat. Uh-oh. Something's going on down there. That old man is my spirit. I love that guy. That's one of the best characters. Still got the shovels. That's how conspiracy works. From one target into 4. I gotta be a lot more careful as we're venturing out. I don't have my armor on, and it's very easy to forget that you're not a bullet sponge. Never understood why people gave money to streamers until I started watching your KSP2 streams. I was learning so much about the game and many other things. I was ready for the next stream as soon as one ended. You're the only streamer I've ever watched consistently at any point, so next month I'll be back to drop the Prime sub. Alright, Jacob. Thanks, man. Thanks for thinking of me. Appreciate it, dude. Some people enjoy the stream for like a couple months and then they never come back. It's all good. That's the business, dude. But yeah, thanks for giving me your time, man. It means a lot to me. I won't let you down. I'll try to keep you entertained and learning stuff as much as you can. And you got gifted a sub. There you go. That's what this community does, dude. Thank you, drummer. Dang it, I was about to do that. So. I appreciate it, man. I joined the stream not too long ago. And honestly, I learned something pretty much every time I watch it. That's the whole idea, Danglesore. I like to play games, learn about space flight, have a good time. That's it. That's my rule. Let's learn, let's have some fun playing games, and hopefully that's enough to keep people entertained. But yeah. I'm glad. It's cool to see new faces in here. It makes me very happy. That means what I'm doing is working, you know, because it is hard to measure your success as a streamer. You know what I mean? Do I have the highest sub count around? No, there's plenty of streamers that have way higher sub counts than me, but have other streamers had this sub count for 10 years? Stuff to think about, stuff to noodle on. As we stream more and more, the idea of being a successful streamer is going to come more into focus, you know? But I mean, it's pretty straightforward stuff. More subs make more money. But I think sustainability in streaming is an important question that, you know, as streaming kind of takes its place among the hierarchy of entertainment mediums, it's important to understand like where it lays, like what's a successful stream. You know, I've had more job security streaming than I've had at jobs that are not, you know, that have financial stability, you know what I mean?
We're the best community in the whole Commonwealth.
Yeah, my community's gonna be better.
Hi.
You here to shop?
Oh yeah.
I'll take a look.
Take your time, sweetie.
Sound like you're on a lot of antidepressants. She only has 337 caps. Anything that we need? I don't have the inventory space to carry all that. Give me 1 second, guys. Yeah, exactly, Tessa. Where's the other vendor? There should be a doctor in here somewhere.
If
Yeah.
you're hurting, just tell the doctor.
No.
Could use some supplies, actually.
Let's see what I can...
615 caps. Here, have some water. Courtesy of Sanctuary Hills. Everybody likes water. Right?
I've never lost anyone before. This failure is new to me.
Yeah, that happens.
Get your lemonade here!
Hey, Deezer.
Fresh lemonade here!
I'll take some.
Enjoy!
Where's he getting the lemons? Yeah, I'm sure that's fine.
I really shouldn't talk to you because I'm busy and all.
Yeah, whatever. Alright, let's hit the bed here. Shut up, Dan.
It's good to see a new face.
Water, sugar, more, more, more. You gonna play Fallout London when it comes out? Maybe.
It's good to see a new face.
You were just sitting there for 18 hours watching me sleep. That's weird. All right, let's get out of here. My character looks like Commander Shepard. I thought it was supposed to look like me. I hear Cave Johnson invested some lemon groves. I don't want your damn lemons. What the heck am I supposed to do with these? Hey, Lucas.
Lucas,
My armor saved many a waste.
let's see what you have.
Don't cheap out on armor. That's a good way to get yourself killed.
I don't. Okay, he has nothing. Excellent. Mr. Shep. Run to the boathouse, run to the boathouse, run to the boathouse, run to the boathouse. Where's the boathouse? Where's the boathouse? Must make the boathouse. Run to the boathouse. Ada! Run! There's nothing around. I just want to make it to the next point. I have no armor, so I'm being very, very careful. See, I cleaned this place up too. Doesn't it look nice? It's a mod, make, yeah. Gotta make it right there. A lot of stuff goes down that four-way intersection over there. We gotta be careful. Thank you. Oh, crap. Yeah, without armor, you can die very quickly. Rules. Remind me again why you don't have armor on. I'm going to get power armor, dude. There's power armor over that hill right there. You'll see. XO1. Might be useful. I'm just being very careful when we go to do it. There's power armor in them thar hills. I hate rad scorpions. I hate them so much. Oh, balls. There's the other one. Man, I'm really happy it just works. It just works. Yeah, me too. Okay. There's a power armor chassis in there that we could get. It's not going to do us any good. Be so careful, dude. This is actually kind of fun. You gotta be careful. Like, we're talking like Tarkov. Get careful.
That's the last of them. If you find any spare parts, you be sure to let me know.
Here we go. Oh, it's already got the keys in it, bros. Oh, yeah. XO1, missing left leg, right arm.
Moving on, people! I want this place searched top to bottom!
Search for this, Gutsy. Run, 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 run. Ada, running through the flames like a beast. Yeah, I'll take that, thank you. Bada boom. Yeah, yeah, remember? Yeah, big bada boom from the cab, remember? Cool robots don't look at explosions. Mark Wahlberg is wearing a hat. So would you say your armor is a crutch? I know you're in survival and don't use VAT. Just kidding. Okay. Speed limit 75. I wish. I mean, in survival, dude, somebody wants to go around and, you know, do this in survival without power armor. Like, Good for you. That's pretty impressive. Not gonna lie. Not gonna question that at all. You can make power armor, but you can't make power armor chassis, Drummer. You can make parts, though. I should be able to do that. I didn't bring any nukes with me, Pigeon. Carberry.
Seems to be growing well.
Seems to be growing well. Yeah, we could do that, Tessa. I'm pretty sure you can just shoot the fusion core, too. Yeah, you could farm gunners. Yeah, exactly. Alright, we saved. Let's get out of here. Actually, I wonder how much purified water these guys have stocked up. Oh. Huh. Did I leave the junk here on purpose? All right, let's head back. It is linked, Boone, yeah. So didn't we figure out that the junk can be linked correctly? Like, I'll have access to that, or is it just the resource? Is it the raw materials or I think it's only for the junk. Everything in the storage but weapons and armor. Yeah, that's what it was, Jen. Thank you. I think you're the one that told me that yesterday, too. Thanks, buddy. don't have any humanoid companions, Tessa. I would have. The base looked like it spawned like that. Good building. Thanks, man. Hey, thanks, buddy. The second human you get. The second companion you get is human Preston Garvey. Yeah. He's trying. I tried to make him my companion so we could go get this suit of power armor, but he really wanted to go take the castle gen. And didn't want to do anything else, so yeah, I kind of wasn't sure how to go about doing that.
If we keep standing in this radiation, you're going to get sick.
I have to remember that place is there.
That's all.
Very well. Enjoy your visit.
Any deviation from standard operating procedures must be authorized by the director.
Sorry, Danny. I shot all these people. That was my fault.
I've never lost anyone before. This failure is new to me.
Hey.
What? What can I do for you?
We need lead for bullets.
Hey.
Yes.
Grab that.
No problem.
Hey.
I'll get it done.
Get that.
Certainly.
Pick that up.
I'll take care of it.
Heads up.
How
Take
may I
that.
be of service? I'm pleased to see you again.
Heads up. Grab that.
I'll take care of it.
Get that. Pick that up.
Certainly.
Take that.
No problem.
All employees, report suspicious behavior to the director immediately.
All right, let's get out of here. Got 15 minutes to get back to Sanctuary. Why not Codsworth? Ada can carry more Pigeon, but not that that matters. I could just tell him to keep picking things up, and it'll be fine. Gunner base. Yeah, JDG. Sorry, I don't mean to keep yawning. That's my fault. My fault. My bad. My bad. You know, I don't want to jinx myself, but I'm surprised we haven't had a random encounter yet. I mean, we did have a random encounter with those rad scorpions, so maybe I'm discounting that. I thought that was a person, that tree stump. I'm like, I'm gonna kill you. During the NSF Space News streams, do you have the noise filter off? Yes. The noise filter is through OBS. Drummer. And I'm not sure that vMix has the same capability, the software that they're using. So I mute the mic when I'm not talking. Eating any death claws for breakfast? No, not yet, Elf. Doom running on a rocket.
This failure is new to me.
Using NVIDIA's Jetson AGX Orin. We're designing Terranar's flight computer to think and act fast. It's playing Doom. Okay. Okay. The Dutch television director for the moon landing is Dev. Okay. Hopefully he's not Destroyer of Worlds. Damn drones. That's what I thought. June 5th net date for Starship. Oh, cool. Yeah, Piggy, they actually are drones in this game. Damn drones. Does this change my plans? No. No, not really. If it delays, I mean, it's a net, so if it delays any more, then maybe, dude. Drummer, if the launch ends up going, so I gotta make plane tickets. We should start EJ and Ernock's Excellent Adventure on the 8th. And if it launches on the 8th, then that's gonna suck. That's gonna really suck. But if it's like the 10th or the 11th, that might allow us to get there in time. Hey, don't touch my power armor. What are you doing? So, what XO1 do we have? We need right arm, left leg. Right arm? Dude, no way. And that's how we got a full suit of XO1. Okay. Will you be visiting Starbase regardless? Yeah, most likely. Wow, that's a pretty strange coincidence.
This should prove interesting. I wonder what you'll build next.
Have you collected all the Enclave power armors yet? I only have 2 suits right now. From them. You know what? We should paint up that XO1. Oh. Actually, while I'm here.
Look alive.
Yes, sir.
Yes! Break it all up into pieces! Oh, oh! It just works. I love gold. Lead. 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 Nice, 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 nice. Seems to be recycling well. Boss, last, did you ever figure out what happens if you assign a settler to the truck? No, I have not. Negativo. Oh, we got a full suit of XO1. We have some Hellfire Mark 6. Almost a full suit of T-51. Another Hellfire. 2 fully kitted out suits of Minutemen T-54 or T-45. ST-45C, that's the armor that I wore for a little while. All right, excellent. Actually, it's 4:30 now. So, we're gonna sleep. Little loot run in Fallout. Is the Hellfire gear from a mod? Nope, that was from the patch that they put in the game, Drummer. The Enclave decided they wanted to go explore the Commonwealth. They tried to get me to explore their bullets, but they in fact explored my bullets. You know what I'm saying? I killed them. I shot them. I shot them and took their stuff. I find that the Commonwealth is a little more chaotic. You are very likely to get ambushed by the robots. You can get ambushed by gunners. You can get ambushed by the Institute. You can get ambushed by the Enclave. It's pretty cool. Rad Scorpions, Death Claws. You just lost a ton of lead by breaking it down now instead of waiting for one level. You would have doubled your lead output. Oh well. What are you gonna do? All right. There was a dozen Creator Club mods that Bethesda made from the recent update. Cool, cool. I saw the update included some Fallout 76 cryptids as well, but I've not seen any. All right, dudes. So here's what's going to happen. I need about 30 minutes to get ready for NSF, the Flame Trench. But if you enjoyed the earlier space news segment that I have, well, now I'm going to discuss space news with my buddies. That should be coming on at the top of the hour. I just need about 30 minutes to get ready for it. So I'll see you guys in a little bit when we start up the Flame Trench. You don't need to go anywhere if you're on the Twitch side of things. If you're on the YouTube side of things, well, yeah, I'm going to shut down the YouTube stream, as is tradition. We'll shut that stream off. If you're here on Twitch, yeah, just chill for a second. Go get something to eat. Be sure to tip your waitress. Make a sandwich. I don't know, take a shower. It's Friday. Drink a beer, get a cold snack. You could do that. So, yeah. I'll see you guys. Will you guys discuss your density too? Sure. Seen the sandwich argument in Fallout 4 yet? No, I haven't. All right. So, I'll see you guys in about 30 minutes. Don't go anywhere. And I'll be back in a moment. Be right back.